Hi, good evening, everyone.
Good evening, sir.
Yeah.
Good evening, sir.
So today is the revision session for the coming quiz. So let's start with week one. We'll briefly go over what we had done for week one, which covered pandas. Let's start. So I'm going to reuse the collabs that we had created for week one. Okay. So the pandas library, NumPy libraries are the bread and butter for data manipulation. We created this is how you can create actually you can pass data in the form of a 2D array or a dictionary as well. Yes, we are using the 2D array, and this is how you can create a data frame. You provide the data, and uh, every list inside this list, so data is a list of lists, so every individual list inside this list is actually a row. And so there are 5 rows in total, and if there are 4 columns, first is name, second is some marks, third and fourth are also marks. Maths, English, and history. So that's how we create it. You can save, of course, data frame with 2 CSV. Moving forward, yeah, reading is something if the CSV file already has an index column, you can mention the index of that particular column, and when you load it, the data frame will be loaded as uh, that particular column is index one. Yes. Is there any question? All right. Moving on. So this is how your data frame looks like. Basically, it has 3 components: the names of the columns, the data inside it, and there is an index column for every row.
Sir, 11, 12, 13, 14 shows the row numbers.
No, they are not row numbers. They are row labels.
Okay.
Okay. So by default, when you are creating a data frame, it does. If you do not provide any index column, by default it starts from 0, as it is doing here, 0, 1, 2, 3, 4. But in case you want to explicitly provide the index values, index labels, then you can do that like this. And these labels don't have to be just numbers; they could be strings as well. All right.
Yes.
Okay. Yeah, in order to access, once you create a data frame, in order to access the names of the columns, you can use this attribute df.columns. It will give you all the names, and here there are only 4 columns: name, mathematics, English, and history. There are only 4 columns, and you can also isolate the index values by df.index. Here you can see that it's a list starting from 11 to 15. Okay, so I think in the when we were taking this session, I had mentioned that the underlying data structure used by Pandas data frame is NumPy array. Okay, so this entire data is being stored as NumPy array. So you can, so this is very important to remember, because just in case you want to convert this entire data into a NumPy and then perform some operation, that is absolutely possible. So if you call this function dataframe.toNumPy, it will remove the index column as well as the column names, right, and give you the entire data as 2D array. Okay, and that this is what it is. Yeah, it is right now. It is looking. We have converted the. Uh, where is T? T must be somewhere or some variable. I believe that T is the NumPy array, and because of that, you are seeing columns and so column names and the index values. They are both starting from 0, because you have just mentioned the data that will be inside this data frame, but forgot to mention the column names or the index values. df.info, one of the very important methods that you will be using frequently. It gives you the number of rows Uh, then number of columns, 4 columns. For every column, it is going to give you this kind of table. The first column is name. There are 5 not null values, and the data type is object. And similarly for other columns also. So object, integer, float, category. These are the data types being used by uh, pandas. So whenever a column has string type values or mixed data types, then its data type will be shown as object over here. If any column has strings and missing values, then also you'll see object over here. If a column has all values populated and at the same time it does not have any missing values, uh, uh, and then it has only integers, then it will show up as int 64. And if any numerical column has only numbers and or missing values, uh, oh sorry, any numerical column with missing values will always appear as floating point number. And if even if it contains only integers plus any missing value, we'll see float 64 as data type. Yes, Devesh, you have raised your hand.
Mhm. Well, in NumPy, with NumPy arrays, we can actually perform various operations like if you want to square all the elements of the NumPy array, or if you want to get cross dot product and all that. And does these operations apply as it is on the rows or columns of a data frame as well?
You have to be very specific. Which operation you want to talk about?
Let us say product.
Okay, if you want to perform dot product, then the data that you have in this numpy array or in this data frame that you will convert it to a numpy array should be amenable for a dot product. If it contains strings, then that numpy array is not amenable for dot product.
Uh, so I can pick a particular row of a data frame, and let us say if I say df and name the column in the square brackets, and at the rate df, and then I name the another column within the square brackets, then
Mhm.
it will perform the dot product.
Yeah, it will perform the dot product. It will multiply. It will multiply the 2 columns that you have chosen uh, element wise, and then provide you the output.
All right, so what is this 64 after int or float?
It represent okay. So floating point numbers, integers, they can be represented with different precision. Int 64 means every value inside this column is consuming 64 bytes. Sorry, 64 bits. Right. So 8 bytes. Of course, you can decrease it to int 8 or int 16, int 32, depending upon your needs. And similarly for floating point numbers, I think there are only 2 categories: float 32 and float 64.
So, sir, if we decrease this 64 number, the input will change.
Depends. It's an intelligent call that you will have to make. Look at this data frame. For English and mathematics, the numbers are never going to be more than 100, right? And for history
All right,
also,
sir.
these 3 columns will never hold any number more than 100. Then it doesn't make sense to store them as in 64, though in 64 or flow 64, even though that is the default data type, you can decrease it. In 64
All right,
is
sir.
a huge
So basically,
the range of in
it
64
reserves
is
the
huge,
memory.
and that is not needed over here.
Basically, all right. So basically, this 64 actually reserves the memory for the is it that?
Yeah, what it means is every element in this column mathematics is represented by an 8-byte integer.
All right, sir.
Yeah.
Sir, you said category is also data type. When will it be category is sure?
Uh, Pardon me, Amrita, your voice is not clear.
Sir, you said category is also data type, right?
Hello.
Hello, sir. Am I audible now?
Your voice is sometimes loud, sometimes feeble.
Sir, I want to ask, like, you said category is also data type, right?
Right.
So when it will be this category data type?
When will it be category? Is it?
Yes, sir.
Okay. So category is a special data type reserved for Pandas data frame only. By default, whenever you're loading any file, it will not assign any column that category type. You'll have to explicitly mention it. You'll have to explicitly change the data type to category. It is used to preserve memory. Let's say a column has million values, but the number of unique values in those columns is only three. Let's say cats, dogs, cat, dog, and bird. So instead of every entry to be stored as a string, cat, dog, or bird, you can actually ordinally encode it. So internally, that is what Pandas does.
Okay,
When
sir.
when you convert the data type of such column as category. All right. Moving on. Uh, okay. So this describe method isolates the numerical columns. So you can see that maths, English, and history. These three columns are isolated. Name column is not incorporated here, and it computes the usual statistics, the number of entries. So this count represents number of not null entries, mean of the column, standard deviation, minimum value, maximum value, and this is first quartile 25%, then median, and then third quartile. Okay, so just in case you want to see the standard statistics of numerical columns, I have in this code snippet, you can see that dot t is mentioned after describe function, so that it becomes more readable. Column names are appear as row index labels, and the statistics appear as columns. Yeah. Now this statement says how to copy a data frame. If you don't set deep is equal to uh, deep is equal to true is set. If you don't, by the way, okay, there are, I think I must have mentioned multiple methods to do it. If you just write df2 is equal to df with ignoring this highlighted part, then basically you have created two references of the same thing, right? When we said deep is equal to true, that means the internal references of the data as well as columns and indices are also copied. In this one, we are looking at iloc method. I hope it is being described in more detail later. Yeah, we'll come there. Info method we have seen, describe we have seen. Yeah. Head and tail methods, just head method, the number of the parameter that you pass, that number of rows from the top are displayed, and similar thing goes with tail. The number that you mentioned as parameter, those number of rows from the bottom are displayed. Next is selection, how to select any data from your data frame. You can select rows, you can select columns, you can select cells, and then you can also select a submatrix, if you call it. You can mention the number of rows, actually the labels of rows and the label of columns, and you can select the data intersecting at those rows and columns. Okay, let's if you just want to access any column, this is the syntax: data frame, and then in square brackets, in quotes, name of the column, and you're going to get a series. Okay, so keep this point in mind. Series is also a very important data set or data type in this ecosystem that you frequently encounter. In itself, it is not that much used, but you'll encounter it anywhere. So it is better to be familiar with it. Right. If you want to select a subset of columns, this is how you do it. In square brackets, you provide a list of columns that you want in the output, and there it is, mathematics and history. If you do this, if you just provide a single column as a list in column selection, you are going to get a data frame, even though the output will only have one column. Keep this point in mind whenever you are choosing columns like this. The index values, the row index values 11, 12, 13, 14, 15, they will be preserved. Yeah. In case you want to, what should I say, reorder the columns, this is how you can do it. Now, accessing different values. Let's say if you want to access second row, third row, then you are going to pass 2 in the iloc method. So df.iloc, and there you provide 2 that will give you access to third row, 0, 1, and 2. Remember that the indexing starts from 0. So iloc is used to access the data frame values as if you were accessing the numpy array itself. Okay, so all the the column names and the index labels are completely ignored. The entire data set is treated as a numpy array. So this data set will be treated like a 5x4 matrix. It has 5 rows and 4 columns. You are accessing third row. So 0, Brajesh is 1, and Charu is 2. Right? So therefore, you are seeing the third record, Charu and her numbers. Right? If you want to access all the rows starting from 0, but before 2, this is how you can do it. And this syntax is also very similar to what you would have used for numpy array. Okay, the output we are checking, it's going to be data frame. The type of this output with the iloc function is going to be data frame. Whether you get a single row or multiple of them. Okay, this seems a little odd. This looks like a series. Okay, maybe you can confirm this offline, but not to worry too much about it. You can easily find out what is the data type of it if you're selecting only single row. Now, this syntax is also very similar. I hope you must have used this kind of indexing for either numpy array or for Python lists. So what it says is start from 0, 0th index, then end position is not mentioned, and 2 means the interval. So every second element will be selected. So 0th row starting from row index 0. So Akash, Charu, and Rajesh. What was our original data frame? It looked like this. So you can see that Akash, first row, Charu, second row, third row, and Rajesh, which is the 5th row. So every alternate row will be selected by this syntax, right? Okay. So we have seen iloc method, how to provide the row index. You can also provide the column indices. So you can see that what I'm saying over here is start from 0, 0th row, then select every row before second row, with row with index 2. That is, you are going to select first row and second row. That is what you're saying. And after comma, you're mentioning the column indices that you want to select. So you start from column index 2 and 3, and 4th will be not selected. Okay, so keep this point in mind. In iloc, when you are indexing with this kind of syntax, the last value in the range will not be selected. Okay, so 2, 3, 0. This is 0th column. This is first column, second column, and third column. Okay. So English and history will be selected. Where is it? Yeah, English and history will be selected, and first and second row will be selected. Yes.
And sir, what is a list : -2?
A list, I think I was giving an example of how similar it is to access the elements, how similar the syntax is to select the elements of a standard Python list, and that in selecting the rows in with iloc method. Okay, so you see this one, and I believe this one. So just focus on the highlighted part. They look very similar. This one and this one. Is that clear?
Yes.
Of course, you can mention instead of providing a range of indices to select rows and columns, you can mention the individual indices as well in any order. 3, 1. That means history will come first and then name. Okay, and this single colon means
Yes, sir.
all the rows.
So that -2 meant choosing alternate rows from the back,
That is correct.
or choosing alternate rows from the back.
Yes, minus sign represents in the reverse order. That's all.
All right.
Sir, this Colab file is available, right, sir, for us?
Pardon me.
This Colab file which you are showing, it is available in our portal.
Yes, I think so. It was shared.
Yeah. Thank you.
Next is
So what this 3, 0 will do?
okay. 3, 0 means you want to select the columns with index 3 and index 0. Okay, so let's look at the column with index 0 and 3. So this is 0 index column. This is 1. English is 2. History is 3. So basically, you are saying that select name and history column. But since you are providing the index of history first and then that of name, history column will appear left of name column, and that is the output. See, history column and the name column. Make sense?
So I was on question. Why it's in the parenthesis in third bracket kind of thing? I mean, it could be any other thing.
Bhavani, sorry, I cannot get that.
Actually, it's look like a list of 3, 0. I mean, 3, 0 looks like a list, right?
Absolutely right. It is a list.
Okay. And I'm asking out of curiosity. I mean, why it is using like this? I mean, is there a particular reason to use it like this?
Yeah, absolutely right. There is a reason. Let me explain it. So
I mean, the column part you are getting, it's like 3 and 0 column you are getting, and you are asking it as a list kind of things.
right. I'll tell you why. See, so if let's remove this for a minute. Okay. So what I'm saying is select all the rows from with the first column. Right. Let me remove this. Let's say if I want to say all the rows with first and second column. Do you think this is correct?
No, that's the increment part also gonna be.
No, increment part is so okay. Let me write this in.
I mean, you read it in the above part that there's this is a form of row column and increment kind of things.
Right. So one thing you can write as this. Second thing, you don't have to write this. So internally, this will get expanded to a list.
Yes.
This means a list of all the elements.
Okay.
Okay. So the general syntax of selecting rows and columns is something like this. The first list is going to have names of the not names, the indices of the rows that you want to select.
Yes,
Is this
because
one?
you are using iloc that part. That's
Correct.
Yes.
Correct. And the second list is going to have the indices of columns that you want to select.
Yes.
Okay, so this is the general syntax.
So
Now
we are
inside,
keeping it as a list. I mean, we are fetching this and we are getting the location as a list, I guess.
right, absolutely right.
Okay. That's why you using this kind of form, that third bracket. I mean, the parenthesis is third bracket. And we call this a bracket. I mean, parenthesis is like something like it's. I think.
Yes, Bhavani. So, when you want to give multiple values for rows and multiple values for columns, you have to use list. Otherwise, there is no option, right? Let's say if you just wanted to select first row, an element, just say one element. Sorry.
I mean, you can use first row like 0.
Yeah. If you just wanted to use select one element, zero first row and the third column, that's what you wanted to select, then you don't have to provide the list, because for the rows and the columns you are providing single values. But in case you want to select multiple rows and multiple columns, you have to provide them inside the list.
Yes.
Okay.
Okay. Thank you, sir.
Sure. Now coming to another method, which justifies providing column names as well as row labels to a data frame, which is the lock method. So in this, in the lock method, we are going to actually use these values 11, 12, 13, 14, 50 from the index column, and the names, column names, name, mathematics, and English, and so on. Now look at this one. This is an interesting one. You are saying select all rows, then comma, and then you are mentioning, remember, if you use iLog based indexing in lock method, you might get wrong answers or you might get an error. Okay, for sure. So keep this point in mind. Here we'll have to use the index row labels as well as column labels. Here we are saying start with column name until column English. Okay, so start. However, this lock method works differently from iLog. This is also using a range syntax. Okay, however, it will include the last column also, name, mathematics, and English. This is the output. Earlier, when we were saying 3, where was it? 2, 4, 2:4, then we were saying select 2 and 3, but do not select 4. Here it is the opposite. If you are saying start from name till the English column, then all the columns, including the last column, will be in the output. So keep this point in mind. Okay, so you can use the same syntax, but the output will differ a little.
Excuse me.
Yes.
Does the same apply for rows also in the lock?
That is correct. Yes, it will apply for rows also.
This is also keeps a list, like, right? I mean, name. Yeah, this one. This is, I mean, the row part, after that the column part, it's also give a list kind of thing. I mean,
yeah,
from
this
name to English.
correct.
Yeah.
This is also a list.
So why don't you use another parenthesis that earlier you used? I mean, why
We
don't
can
you
definitely do that. We can definitely do that. So there are multiple syntaxes to use. Write the same thing, and let me write them. So let's say you do not like this syntax for a second. You do not like this this way of writing thing. So what you can do is you can put this entire thing into a list, right? And also include the maths column.
If we just, I mean, do the previous thing like name and English by like a list, it will give an error something like this. I mean, why do you include maths here? I mean, is there a reason here?
Yeah, there is reason. See, so recall that when we are writing something like this syntax, start from this and here. This is basically this is basically a list, because it's going to have multiple values, starting from name, then mathematics, then English. So it represents three values. Okay. So here we are only mentioning starting point and end point, and all the values in between will be taken by default. However, if you are using this list format, then we'll have to mention the all the values in the sequence that we want.
Okay.
Explicitly. Okay. Yeah. Then here, you can also use the accessing these selection methods to assign something as well. So the first element of the data frame, top left element of the data frame can be assigned value Anand with the syntax. Yes. Is there any question?
Excuse me, sir.
Yes.
Sir, in this cell, this where you are writing Anand, so this change is being made in place, right?
Yes, in place.
Okay.
Okay. So here you can see that DF was something else earlier, but after setting this, Akash was changed to Anand.
Sir, there was one message in the message. Hope you are concentrating on Quiz1 probable questions. So,
Yeah.
we are
So,
going to do that now, sir.
so what I can say is,
Sorry for
whatever we are
disturbing.
covering
So I
will be
think
used.
just
Yes.
the I log this part, we are assigning the value Anand to this part, right? Okay, sir. ठीक.
So, what portion of questions we can get in this Pandas in the Quiz1, sir?
All the things that we covered.
Yeah. I mean, for the entire Quiz1 question paper, maybe 20%, 30% of that will be Pandas, or something
See,
like
there
that.
is no such specific number, but if you want to get an estimate, you can look at the previous year questions.
Okay, sir. Because most of the questions are asked from Scikit only, SK Learn only. That's why.
Oh, I see.
So if we could concentrate on that also, it would be very good, sir.
We'll come to that part also.
Sure, sir. Thank you very much, sir.
So
Sir,
here,
it will not be in place, right? Because they are not written in place equal to.
Sir, why don't we take one question paper? Then probably that gives a flavor of all what it is.
that's a good idea. However, let me finish this. Then we'll take questions from all the previous year questions, whatever you want.
This will give the concepts. So this is also important.
All
No,
this that we are covering
Nothing
will
is
be useful for your, for your
nothing is underestimated. What I am telling, it's all because it is quiz focused. So we don't know what is the focus of questions. So that's better thing to start with the questions. Then really we get back on this one. We don't need to really work a lot on that one, but just to get a flavor of it. So fast rush, then really come to the details.
We can cover the questions, but let's revise first. Yes, Dev.
All right.
Sir, are we going to take doubts in this session?
Pardon me?
Sir, I'm saying, are we going to take doubts in this session?
Yeah, sure. If you have questions, anything, understanding anything that we are covering right now,
Actually, I have a doubt. I have a doubt. In one of the previous year question, may I ask it right now, or you want me to ask it later?
Is it related to pandas?
It is related to regression, linear regression.
I see. So, yeah, you may ask when that topic is covered, for sure.
All right.
So let's move on.
Sir, good evening.
Yes.
Sorry to disturb you. I have one quick doubt in the same question. In iLock, you told that feature in the column part, the last column won't be picked, right? Some madam also asked. The rows also, it is the same behavior, or?
Yes. For rows also, it will be same behavior.
Can you go scroll up, sir? I think earlier when you the result, the all rows was selected. I think above that.
This one?
No, iLock, sir. Above
the, here?
Yeah, 0 to 2. Oh, hold. Okay, got it, sir.
Right?
Okay, so yeah, got it. Thank you. Sorry.
All right. So lock method, just like iLock method, you can provide. You can use this comma syntax. The first value will be rows. The ID of the row, or the list of row IDs. And similarly, the second item could be a column or list of columns to select. Now we come to conditional selection. In case you want to select the number of rows based on certain conditions. And here you can see that we want to, so first condition says all students who got less than 80 marks in mathematics. The second condition says all those students getting 45 or more marks in English. And there's an AND operator over here. That means you want to select the conjunction of both. Okay, not disjunction. That means not union, not the union. The rows for which both these conditions are true. And if you want to do the disjunction, that means either of the condition is true, then you can use the OR operator. If you want to negate something, the output of any conditional operation, then you can use this tilde operator. So this condition itself says, the highlighted part says, mathematics less than equal to 80. However, you are inverting that condition by putting a not over here. That means all the students are getting less than 80. More than 80. So it is less than equal to 80 when you invert it more than 80. Moving forward, yes, you can also use functions to do the conditional selection. If you define a function like this, by default it is assumed that the X is a data frame, okay, on which you want to use this function as conditional selection. Okay, so that's the end of part 1. We'll briefly go over this part also.
Sir, in the above, when you assign ilog 00 is equal to unknown, then how is it in place? Is it changing? Because we have not written anywhere that it is in place is equal to true.
Right. So in place has two meanings. In place means logically in the original variable itself, or in place is a parameter that you pass in certain methods of Pandas. So when I say in place, it is changing. That means we are changing the original data frame itself.
No, sir, but how is it changing original data frame?
So that's the syntax. In order, if you want to change the value of any cell, okay. Give me 1 second. I'll reshare it. Right. So there it is. So just ignore the assignment operator for now. Let's say it is something like this. Okay. So by this, what you are doing is you are accessing the first element, top left element, or the element at index 0, 0. Okay. You are accessing it like this, and then what you are doing, you want to change its value, so you are assigning another value to it. Make sense?
Yes, sir, we are assigning, but I'm not getting how is it originally changing. I thought it is for that.
How is it?
Only. How is it changing the original data? I thought it is for that only.
Because this df2, so when we are talking about df original data frame, I am talking about this data frame referred by df2 variable. Okay, so this df2 data frame, after this executing this statement, will have Anand in the 0, 0 position over here.
Okay.
Hi, sir. If I may explain her question, what she was asking is, sometime we explicitly mention in place equal to true. Here we did not mention that, so maybe this is by default in place is equal to true.
See, this is so in place parameter is used with methods. Here you are not calling any method on a data frame. You are accessing an element and assigning its value.
Thank you.
Yeah.
So in lambda function, when we define lambda x, means that function I will apply on each and every feature.
Mm-hmm.
Could you explain actually?
No. So okay. So I think
Lambda, last one, lambda.
Okay, so this lambda function is expected to return a Boolean Boolean series basically, and this x. So by the way, this lambda function is very closely attached to this data frame df on which it is being called. Okay, remember this point. I think we must have seen this. Look at this. So when we call this function on the data frame, it is going to give us a Boolean series.
Okay, for the marks greater than 80.
Yes, marks greater than mathematics marks greater than 80. So see, when you are passing this data frame, this x, when you're defining this data lambda function, it is assuming that it is going to be called on a data frame with mathematics column with numerical values.
Oh.
Excuse me, sir.
Yes.
Sir, can I ask you a question? Sorry, go ahead.
May I proceed?
Yes.
So the line in which you have used the lambda function instead of writing x dot maths, can we write x and maths within braces?
X and mathematics within braces.
In the square brackets, I mean.
Yes, of course. Okay, so what you're saying is, if I get your point correctly, what you're saying is, can this be written as something like this? Is that the question?
Yeah, that is what I am asking.
Yes, it can be written like this.
Okay, sir.
Sir, can I ask you a question, sir? So
yes.
So in the lambda, the x refers to the complete data frame, right, sir? Say, for example, you want to apply this to some 2 or 3 columns. Is it possible over there?
Yes, it is possible. Let's say you want to get do something like this. Again, I'm going to change the commented function. So let's say we do this, and then and operator, and then we write x dot eng marks. English marks also have to be greater than equal to 40. You can use it.
Okay. Here the x refers to the rows, right, sir? Not the columns. X refers to the rows, and
x refers to the data frame itself, entire data frame.
Entire data frame, and loops over the rows. It iterates over the rows.
I wouldn't say do not use that iteration analogy anymore, because you're when you are performing this operation, of course internally it will run like a loop, but conceptually what you're doing is you're applying this operation on every value inside this column mathematics, and since it's a conditional operation greater than equal to, then every value in the output of this condition will be true or false depending upon the value in that column is greater than equal to 80 or not in that row particular.
Okay. Yeah. Thank you.
And same thing I've explained here also. So this df, if you provide the lambda function inside the argument, then it will give you the rows that you want to select. However, if you use the same function in this manner, that means the data frame is an argument to this function, then it's going to give you a series of Boolean values.
So can you scroll a bit, sir? This is actually the lambda that you defined over. Okay. Okay. Sir. Okay. Thank you.
Sir,
isn't it giving a series right now? When you're just applying the condition for mathematics, it's not a series.
So okay, when you are doing this,
yes,
right, you are passing this data frame as an argument inside this lambda function, and you can see over here, it takes the data frame, it takes its mathematics column, and then returns you a series with Boolean values depending upon individual rows have 80 or more marks or not, right?
Yes.
That is one way to call it. If you call this function as to select certain rows inside data frame, column selection format or row selection format, this is how it will directly give you the rows that you want to select.
Okay, is it a data frame or is it a series right now?
It's a data.
Okay, it's a data frame. Okay.
All right. I will request all of you to please hold on to your question. I'll complete the next part of Pandas also. Okay. Then complete the review quickly, and then I'll take the questions. Okay, this was the second notebook or second session that we covered on Pandas. Right, we loaded this CSV file which had action movies, a bunch of columns: movie ID, movie name, year, certificate, run time, and so on and so forth. Usual methods: df.column, df.info. If you want to compute mean of any particular numerical column, you can isolate it and call mean method. This was slightly interesting. You're applying a type function on every value of the year column, and then getting the distribution of values. So here you're seeing that 8,000 values are floating point numbers, and 44,000 are a string type. Yeah, of course, if you want to see the distribution of any column, value counts is the method that you use on that column. Again, selection. We have seen this. Now we had seen another method, I believe, query method. Yeah, there it is. So we had seen query method to select. Here, what you can do is you can use the column names as variable names inside the expression for selection. Okay, and of course you can use and, or, and not keywords that you would have used for forming conditional expressions in Python itself, right? But for selecting rows in Pandas, earlier we were using ampersand sign, vertical bar for all, and tilde for not, right? However, if you are using query method, you can use and, or not. Somebody has a question?
Sir, let us say if any column of data frame consists of only strings, then the type of that column will be object, right?
Correct. That is correct, yes.
So, and there's nothing like type str for any column of data frame.
Right. For yes, when you call the info methods, you will never see string over there.
But for a particular cell, it could be string.
Correct.
But for a particular cell, it can't be object.
No. So query method is another way to cleanly write or easily understandable conditional expressions. Then right, if any column contains only string values, then you can conveniently use the syntax, the column name .str, and the methods that come with string objects. For example, contains, lower, upper, and so on and so forth. Okay, so all the movies which are action as well as drama, you can select them with this syntax. I think in place, not in place, we are going to look at that again. So just in case you want to rename any column, this is a syntax. You call the rename method. Then you provide a dictionary. In the dictionary, the key value will be the old column name, and the value will be the new column name. We converted star to actor, star ID to actor ID, total collection to revenue in USD, something like that. And we are calling in place equal to true. That means it's not the output of this entire expression will not be a data frame, right? It will not give you anything. It will give you none. And all these column names will be changed in place in the original data frame itself. Then we saw how to sort the data frame based on values of a column or set of columns. Here we are, sorting the values based on year and movie ID. And you can also provide this parameter ascending. the size of the array that is provide in the ascending parameter has to be same as that of we provide in the by parameter. That means the columns, the set of columns that we provide over here, we have corresponding true and false for every column. So when we say year ascending true, that means this is our primary column since it is appearing first. Sort it by year column, and whenever there are ties, two columns have the same year, then use movie ID as a secondary column. Okay, and we are setting false over here. That means you are going to sort all the rows by increasing year but decreasing movie ID. Moving forward.
Sir, sorry to interrupt. Can you please explain the ascending true and false part again?
Correct. Sure. Okay. Look, for a minute, just ignore this. Look at this.
What if there?
Yes.
What if the number of features are very large? Then we have to write as many false as the number of features.
As many?
Sir, I'm saying in the data frame, if number of features are very large, then we have to write many false as there are features. The one with the which is true.
You have to type as many features for exactly doing what?
Sir,
I'm saying if the number of features. I'm saying if the number of features are very large, then I have to write too many false, right?
Yes,
No,
yes.
anyway, you will be giving the list in the by parameter, no sir. The list that is given in the by parameter only should match with the true or false here, correct?
Absolutely right.
Not
Yes.
the entire data frame. Whatever you are sorting by the columns, for that you are mentioning whether it is descending or ascending. That's all.
Yes, that is correct.
Am I right,
You
sir?
don't, yes, yes, absolutely right. You don't have to write name of every feature.
Sir,
yes.
The two correspond to year, right? So data has to be sorted by year, right?
Both the columns, year and movie ID.
And what does the false signifies here?
Right, right. So ascending true means increasing order. Ascending false, that means decreasing order.
So when you are listing two columns, no, year and movie ID, ascending true is applicable to which column?
Ascending true is applicable to year column. They are matching element wise. So year, increasing order, movie ID, decreasing order.
So for each year, the movie ID will be in decreasing order.
Correct.
That is, if the years are same for any two records, then it will go for the movie ID. Otherwise, the first preference is given to the year column, right, sir?
Right.
When the year are same, then we'll check the movie ID.
Yeah.
Okay,
is it right only when there is a clash, now second column is going to be used for resolve?
Yeah, what she's saying is correct. I mentioned it, same thing, right? So
yes, can you please scroll up to a little bit? Just a little. Yeah, there's in place equals to. What's the significance for this?
so what it so if let's say I do not write this for a second. Let's just assume I do not write this. The output of this will be a new data frame in which the older column names will be replaced with the newer column names. But if I set in place is equal to true, that means I do not want another copy of the data frame. I want to make changes in the original data frame itself.
Okay.
Yeah, this is a very clean way of writing a list of operations. on a data frame. All of them could be written, each operation could be written, in a separate line itself, with its own object, data frame, df something. But you can stitch together all these operations and write them in this clean way. This is called method chaining. Moving forward, where was it? Yeah, I think this is an important method to remember. Apply. What we are trying to do over here, we are selecting runtime feature, then filling the missing values. So fill n is used to fill missing values with 90 minutes. Then we are replacing any unnecessary commas, just removing unnecessary commas with this method. Then we are calling apply method. And by this apply method, what we are doing, we are replacing space min with empty string. That means we are removing this altogether, so that we can convert whatever is remaining, which is just a number, we can convert into a numerical value. We are converting it to float over here, right? Now, once we have isolated the number of minutes a movie runs for, then we can use it as a feature. So that's the purpose of this set of operation. What's next? Yeah, how to insert any row in your data frame. This is how you can do it. So you create a list with same number of elements as there are number of columns. Hope it is somewhere there. Dot lock. Then use this lock method. The index value, row index value that you want to use, and then you provide the array or the list.
Sir, that 52452 number represents column index or row index?
No. It represents row label 52452. Siam Marmal movie. This one.
Okay.
Since we are using lock method, it has to be a row label. It cannot be row index. How to read columns and rows? You can use df.drop index is equal to this much, or you can use columns. You can drop columns also. Just I float quotes. Okay, this is another operation, another example of using chained operations. Okay, this assign method, I don't think we covered earlier, but it's quite useful when we are chaining multiple operations. And with this, you can create any new columns that did not exist before. Here we are creating this column, receive critics award, and applying some function. You can also initialize with a constant over here, like. Then reference, shallow copy, deep copy. I think we have seen this already. Next is finding duplicate values. So there is a method called duplicated. Get this score under. So it's going to give you a series. I think it's going to give you an out. Basically, a series of Boolean values. If a particular row is duplicated, then you are going to see true over there. Everywhere else it's false. So there it is. It is, remember, negation of duplicated. So the rows which are original, they are true. Everything else is false. So what is the data frame you're talking about? Yeah, look at this. This is our original data frame, and we are using name. I believe name, yes. Only name column to detect duplicate rows. So Rajesh and Akash. Akash is repeating over here. Rajesh is repeating over here. So the last two rows will be marked as duplicated. The first 5 rows will be marked as original ones. How to remove missing values, how to get missing values. So this is how you can get it. Of course, we are getting the missing values for every row. Probably this is not what you want. Yes.
So the interpretation of access number is same for all types of functions.
Access is equal to 1. Yes.
Sir, 1 means column, 0 means rows.
No. 0 means column. I see. It's slightly. I think I have explained this. So when we say x is equal to 0, that means y-axis. X is equal to 1, that means x-axis.
Alright, sir.
So, if we don't put x is equal to 1 here, then
So x is equal to 1 means x-axis. That means you have to perform this operation, whatever this operation that you are performing, parallel to your x-axis, the chosen axis. X is equal to 1. That means x-axis or horizontal axis. And what you are trying to do, you are summing the number of missing values in this data frame. So you are seeing that every row, for every row, you are seeing the number of missing values. So the left hand, the first column is the label rows, row labels, and the second column is the number of missing values.
Sir, if I don't put x is equal to 1 here, so it will take by default x is 1.
I think by default it will take x is 0.
No, sir, it will just give the sum of null values in the entire data frame. It will be a single value.
I don't recall,
Why
but
don't you just try it now?
okay.
Maybe you should try this one.
Actually, if you do sum.sum, then it would give you the single value, the sum of all the null values. If you go df.isNull.sum, then it would give just column wise. If you don't give x equals 1.
Correct. Yes.
Why don't you just remove x is equal to 1 and keep the brackets empty for this one?
See, if I need, you are right. I can check it. I'm pretty sure if I do not mention x is equal to 1, it will give you 0. You can confirm it. If I had to run this, I'll have to upload the movies data set. It will take a lot of time.
Sir, how can it give 0, sir? Because row also will have, if row is having in some row, if there are 1 in A, then some column will have that 1 also there, no? So it will not give 0.
I mean, he meant axis equal to 0.
Axis equal to 0, okay.
Yeah.
Axis is equal to 0, okay.
Will give you the number of missing values in every column.
Correct, sir. Yes, sir. Thank you.
Here I was explaining that x is 0 is y-axis, x is 1 is equal to x-axis horizontal. Okay. Here we can check value counts. Okay, we have seen all of this. I think we can close the revision of Pandas here. If you have any questions, please go ahead.
Yes, sir. I have it on. So may I share my screen? It is related to linear regression.
Okay. Yeah. So Devesh, please wait. Manoj is going to cover that part, and then you can ask that question.
Sir, I have just a question. Like, we inserted a row into the movies dataset at the end. So if you choose any other index, it will just replace. Or if you want to insert in between, maybe we need to do a for loop and change all other indexes and insert something like
that. You can do that. So see, if you choose any other index, which row index or row label, I should say, that already exists, then it's going to replace the value, replace that particular row, right? That is one thing. Second, let's say you insert the row at the bottom and then you want to change the index, you can do it, but then you have to carefully create a list of row labels and then assign it to df.index.
Okay. Thank you, sir.
Yeah.
Hello. Hello.
Is there a break going
No, it'll start. So, okay, you want okay, first.
on? Can you please share the collab file also? It will be really helpful.
Okay, here.
I think it's for previous week live session. Okay, thank you.
Right, Bhavni. It is from the week 1 live sessions. So I'll paste the links again in the chat box.
I did it.
Someone did, I guess. Yeah.
Yeah. Okay, then let's call it. So, we'll have a plot. Is this kind visible?
Yes, sir, it's visible.
Okay, thanks. So I'll cover week 3, which contains mostly related to pre-processing the data. That how do you pre-process the data? So there are like numeric transformers such as standard scalar, min max scalar, then max absolute scalar, and then like categorical transformers, which are ordinary encoder, one hot encoder, right? Then feature selection is there, wrapper based, filter based, and then there is a PCA, and so chaining transformers is column transformer and pipeline. Okay, so let's see. So this is also from previous session. I took on week 3. Let's see. So what we did is we had this data set, right, which is on like housing prices, okay, which is like a regression problem, because our target was sell price, that make a prediction on sell price. But before we go and make a linear regression, we need to pre-process the data, and to pre-process the data, we have some things like removing the null values. So before I go and remove null values, I need to check that are there any null values present or not in my data set. So if there is a categorical data set, then I know that if there is something missing or which I don't know, are all I want to remove. Like let's say question mark is there, unknown written itself, like unknown, or NA, if NA or something, some other strings are written which are not part of our normal data, or which we don't know about, that those all are missing values. Okay, so what we do is we either you convert all of them to np.nan, which will remove it completely, and it will show that np.nan means nothing is there. If there is written something to represent a null value, you can make it as a null now. Then you can go ahead and do this like is null dot sum, so it will give you sum of all the null values, and then you can check what are unique values present in each categorical type columns. So that you can do using like select d types as object. So if you run this, then you'll have all the columns which are categorical in data, which have categorical data, right? So you can check normal what are values present in it. Then you can go ahead and clean whichever way you want. Okay, so after you look into the data, generally first step is how to handle this null values, right? Since you know that there are null values present in this or that way or something, right? Yeah. And so since you don't want to uh, have like biases with test data set, and you don't use your learning from the data set and use it on test set. So what you do is you do a train test set, right? And for that there is a API like apply train test set. So there's a test size you have to give, and this is for the consistency of the code, that every time you run this notebook you will have same result. So test size is important, that you should give. So generally we have like 20 to 30% of test size, we keep it aside, and then on training set we do all the pre-processing, everything we learn from them. Like simple imputers, like we use any statistical imputers, right? So we learn from the training set, then use that learning and pass on to the test set. So that is the idea. So we do this thing, splitting.
Excuse me, sir.
Then yes.
Sir, I have a basic question. Why is it that we do the train test split before the pre-processing?
Okay. We don't want to use our learnings, which we use in training, to go and apply it on test set. So we don't want to learn from the test set. Okay. So if you do that, then all the learnings from both will be accumulated, right? So that is called data snooping. Okay. So the term is called data snooping, but that means you can't learn from the test set while training the model. Okay. So you do train test set and learn from training set only. So learning, you don't do it on test set. You just do predictions, or whatever you learned, you apply there, something like that. So fitting will only be on training set, right?
Okay, sir. Yeah. Understood.
I mean, you are doing the transformation for both test and train. I mean, we can do it for just one set, and after that we can do the split, right? The X train we are splitting for train and test, the transformation part. But we can do the transformation then split it. I mean, is it?
So, so let's say you do this
I mean,
categorical encoding. Okay,
yes.
categorical data you have, you do encoding on that, you convert them to numbers, and then you split it. That's okay, because there is nothing, uh, nothing, any kind of thing you learn from the training set,
Yes.
which is gonna change, right? So it's just a numbering
I
of.
mean, the transformation part is data pre-processing. So if I do it after the splitting and before the splitting, that's gonna be same, I guess.
Yeah, for categorical data it's gonna same, but for numerical data, if you are
I mean,
using
for
mean,
numerical
median,
data, we don't need to transform because model needs numerical data, right?
yeah, but you need to remove null values. You
Uh,
want to scale them. You want to maybe create new columns as well, like something from three changes. So that is, you
Feature
can't.
engineering you're talking about for new column, we do that for feature engineering. I mean, I'm asking that part.
Yeah, you can't do it on training set, right?
Okay.
I mean, you can't do it from on the whole set. You need train set to do all of this.
I mean, what could be the reason for this? I mean, what would be the effect if I do this? For
If
the
you don't, then the effect is, let's say you, uh, then you will not have perfect predictions on the validation. So currently we are creating this test set, right? This is a
yes.
validation set in our case. So you will have a biased validation set, and you will have some some kind of result, like scores, which are not
There's
reliable now.
two possible. I
Whenever
mean,
you
two
use on
possibility we
test set,
can split the test and train set. There's a random test split and something straight. Something like stratum or something like this.
stratify.
Stratify. So if I that use the second thing, the stratify, and then do the I mean before I mean using the stratify, it will be gonna like uh, show the overall distribution. I mean the test distribution will be the overall distribution. So effect. I mean, is there will be an effect if I do the transformation part after before this? I mean,
So if you don't use stratify, then that actually stratify will help you to have a
and
consistent
this data
distribution.
set you are doing, I mean, the part we are doing, it's for a only on data frame you are using. If I have a two data frame and I have to go back and forth for two data frame, I mean, let's say I have two data frame, DF1 and DF2. So my oil level, I mean, the prediction level is in DF1 and my features level in both DF1 and DF2. So, I mean, how should I do the test train split? This, I mean, how should I approach this?
So okay, see, the data frame for which you don't have labels. Okay, you
Okay.
can't use it for uh,
I mean,
training or validation.
let's say I have a level. I mean, it's supervised learning because let's say DF1 have the labels, Y prediction we have to get from there, and DF2 have the feature sets.
Yeah, that's what I'm saying. You don't have labels for DF2, right? So you
No, I
can't
don't
use
know.
DF2 for training or validation. You just you can't have, you can have predictions of it, that I have this test set and I want to
Well,
predict
DF2
what.
have the features. I mean, DF2 have the features of the sets. I mean, features of the level sets.
Yeah, features of labels.
I mean,
What is features of labels?
feature list kind of thing. I mean, if let's say that we are predicting the cost of wine production, then DF1 have the wine production level cost, I mean, the level part, and DF2 have the every other possible thing that, like say, we have to predict its other kind of cost and other kind of thing that related to the prediction of cost that have it, and like this. I mean,
So okay, so is so okay. Wait a minute. So let's say df1 is there, it has label. Df2 r doesn't have label. Either this case or other case is df1 itself is a label and df2 is a features. Which one you are talking about?
df2 is features and df1 is label.
Okay, just that, right? So that means you have y and x.
Okay.
You are calling them df1, df2. That's your choice. But that is y and x. You have now x and y. So now what is the issue? You have x and y, right? So you can do train test split now. Put df1 and as so that is your
When
x.
should I do the transformation? I mean, should I do the train test split, then after the,
Yes.
I have to do the transformation, or before doing the transformation, then do the train test split? I mean,
Always do the splitting, then do the transformation. Okay. Just uh, do it like that way. It's a practice, good practice. Okay. Otherwise, you can do it, but there are gray areas like when you shouldn't, when you should. So it's a choice. But uh, for me, I always do it. It's a good practice.
okay. Thank you.
Yeah. Okay. So yeah. So let's say we have null values now, and we want to impute them. So I can use simple imputer. So simple imputer has uh, several ways to do it. Me. So I have this simple imputer with me, and
Hello.
hello.
Yeah, adding to that previous question, I have a doubt.
Yeah. Okay. We'll
Like,
take it later.
no, it is on this train test split only.
Okay. Okay.
Okay. So now the question that girl asked, it is something like we have a data of say 1,000 data points. Okay. I and suppose it carries about 500 null values. Okay.
Mhm.
Now if I split first into train and test, both train and test will have null values.
Okay.
Okay. Then if I do the transformation on train
Mm-hmm.
and apply it on test,
Mm-hmm.
okay. So I did simple imputer and converted null values into say mean.
Mm-hmm.
Okay, something. The same will not get reflected in test. So test data will be something different and train data will be something different, no, in the structure.
So no, see the assumption of machine learning, right? See, when when we want to apply a model later on, the assumption of a machine learning model is that the data is coming from a same distribution. Okay, so if you are changing the distribution in any way, then your model is not going to work for the different kind of distribution of data, right? So data is coming from the same distribution. That is the main assumption of machine learning. Okay, so that's why we do what we do is we take training set and we do all the pre-processing on that. And since the test set is also coming from similar distribution, that's why we can remove all the null values in test set using the learnings of training set. So whatever mean or median you got in your training set, that is the that we consider for the whole population. Now you can say something like this. Let's say that is a sample, but whatever you got, we take that as a standard for population, and then whatever new data set coming from the similar population, we will use same mean which we learned from the training set to replace them. Okay, replace the null values or anything we want to do with test set, we have learned from the training set.
So you mean to say we'll do all the pre-processing on the train, and we'll have to apply the same on test again, no?
Yes.
So the question actually that girl asked was, why can't we do it on the whole data first and then split?
Because then you are using the learnings from the training set, let's say the whole set, and then you transformed it, right? So let's say you make a model out of it. How will you predict the
Then there will be no difference
scoring?
between train and test.
Yeah, you will
So
not have
maybe you
another.
can explain it when you reach that fit transform part. Maybe until then, like when you do that, maybe
No,
you can explain.
anyway, we are taking the random data. No, random data when we are taking, it won't differ at all. No,
No, it will. You see, you don't have now. See, you have limited data, right, with you. Some limited data. Let's say 3 GB, 4 GB, 10 GB. Now you want some. You want to keep aside some data, which you consider them as a like that as a test set or validation set. So that later on you want to make predictions for something which you haven't seen yet now, right? Yeah, like that is the main goal of machine learning, that you want to make predictions which yet not happened. That future is something you want to predict. So how good you are with future, that you can't say now, right? So now what you have is you have some data which is test set, validation set, and on that you make this scoring. Okay, so on basis of that you say that my model is this good. Okay, then you apply it on the something real life, that okay, then okay, if your model is so good, let's test it to the real life, predict that one. Then we predict it, and it might be true or not, that time will tell. Okay, so
that is what exactly my question is. If that is the case, then X test data we have to keep it not imputed, no? If we impute it, it will become similar to the train data.
No, it will. We have to make it similar. See, whatever learnings we did from training, that is fitting only. See, I am doing fitting only on text train, right? On X test, I am only transforming it. So I never learned anything from a test data. So now whenever new data comes up, I create a pipeline. The whole pipeline I'll create, which will directly do all the learnings from the training set. It will have it stored in it. It will just impute that.
Yeah, I understand that, but my basic question is this split we are doing before learning.
Yes.
Okay. Now, the question is on train data and test data. Why should I do this transformation of this replacement of null values separately, and or why can't we do it on all? Because it is both are happening before the learning, no?
Both are happening before the learning. Yes, you can do that. So that's what I'm doing. See, I already transformed it, right? I have transformed my X test before learning, but I can't do it on the whole thing. I can transform it. I can do everything like, but I can't learn from it. That is the whole thing. I have to keep it aside. Okay, I can't learn anything from the test set or validation set, whatever you call. I can't do that. That is my limitation.
Yeah, but so that before learning, we can do on the whole data, and then we can split it, then do the learning on train data.
No, see, that is not the only learning happening. There are not the model. So see, before model training, there are other learnings also happening. That what is the mean of the data? What is standard deviation in data? How range is there? So this all learnings are happening internally. You don't see it. I mean, you are not trying to see it.
Okay.
Okay. So for example, this most frequent, right? How will I know what is the most frequent in my data set? So it could change, right? Let's say my training set was, let's say I have this categories: cat, dog, another dog and dog. I say what is the mod of this? This is my training set, okay? This is my training set. What is the mod of it? And you'll say, okay, it's a dog. Then my test set is there, which is like this. So this is my test set. Still, I can't do anything. I have to, if there is a null value in this, let's say this is my null value. I can't learn that. I can say that I merge it. If I merge both of them, X train and X validation, then cat is the mod. And let me impute cat. No, that's how it doesn't work. You have to use dog only, because you learned, you made a rule that I will not learn anything from test set. The way you splitted might be wrong or anything. Okay, that whatever reason you did this way, that's another story. But you have to use the learning from training set and use it for test set. Okay, so that's how it works. You don't do learning on test set.
I got it.
Yeah. Okay. So yeah, so in simple imputer we have 4 kind of strategies that you can impute. Mean is there. Mean is summation of all the numbers divided by n. Then median is there, which is the 50th percentile. Then most frequent, so that is mod of it. So you take frequencies in count, and whichever is the highest frequency, that is the most frequent number. And then for some reason you want to impute constant, that this values other than the best prediction or best replacement of a null value is a constant. That also you can do it. So in many cases you might come up with 0 or something, that if nothing is given, then there is highly likely that it's a 0 value. Okay, so something you want to do it, then you can do that constant or something. So it's very straightforward. You have to create an object of a simple imputer. So this simple imputer, and you create an object. So this is the object name SI I use. You can use any name. That's your choice. And you have to give strategy. There's another value you can give, like what is null value or what is missing value, right? So missing values, by default it's np.nan. But if you have some other kind of missing values, for example question mark or unknown or anything else, you can do that. Okay, you can use those values as a missing value, and then you can remove them. So that's also a choice. But by default it's null value. So if I haven't written anything, that means I want to impute null values, np.nan specifically. Okay, we know.
Let us say if you
Sorry.
So let us say if you specify the missing values, then this simple imputer function will not impute for null values.
No, it will not impute for null values.
Once for interrupting, can you please show how can you get the documentation for this simple imputer?
This I question mark and I run this, so that's how I get the help. So any this whatever you call this object class, you can write the class name and put a question mark in front of that to get the help.
Okay. Thanks.
Yeah.
So if you have a mixed value, so np.nan and unknown, a question mark, all these things are there in the same column. But you are identifying with these questions. But how do you impute with three different null values there?
Yeah, you can convert them, all of them, to a values. Okay, so now let's say 4 type of values are there. You change them, all of them, to one value, any one value. Okay, that this is the value I'm choosing to replace it. And
who's change that? You have to really convert that all the different things to uniform one. Then I have to impute that one. Is it?
Yes.
Okay.
Sir, in quiz 1, will we be asked to find, will we be asked to find KNN or missing values, imputing using KNN imputer by giving a
No,
matrix form?
there is no KNN imputer.
Okay. Okay. Thanks.
Okay.
Sir, can I use multiple values and missing values? For example, we have two types of
One, we
missing
don't
values.
have collab environment, no? In
Sorry.
quiz one, we don't have collab environment, no?
No, this is quiz, so that will be MCQ questions or NAT and all. Like a normal quiz you used to give in to TCS center.
So how do we really get the questions then?
So have you seen the mock? The questions are as equal to mock, so
Yeah,
you can.
we see in the mock, yes.
Yeah, you can solve it. You have to use your knowledge, and then you can do it. So it's like
Oh, we don't
how you
need to
did
run it.
Python. So for Python, how you do it?
Python, not in
Yeah,
the environment. It is only objective questions.
yeah, it's the same thing, right?
Okay.
Yeah. So this is just a addition of Python with sklearn.
Okay.
Okay.
So can I use multiple values in
What was
multiple
that?
things in missing values? Like missing
Multiple
values
values in what?
like missing values equals to comma,
No.
yeah, question mark and unknown and something like that.
Yeah, that's not supported. So either you have to change it to one value, some one value, okay, and then you can do it. So multiple values are not supported in that. You can't give array or anything. Only a string or np.nan or something like that is acceptable. One value, and also that also acceptable, but only one.
I think that's why we use pipeline or something like this. I mean, for multiple processing, we use the pipeline to get the return.
Yeah. No, that is pipeline is also there.
I mean,
But if you want to replace,
we
so
can use the multiple transformation like simple imputer or scaling part, then
yes,
do the pipelines part.
yes, definitely. So that's how we do imputation, and then there is like so.
I
Let's
mean,
say this is a
can I
constant
use
example of a constant and all.
no,
So
asking that can I use simple imputer for multiple times like his ask something like this, I guess.
yeah, definitely you can use as many time you want. I mean, you have to remove null values, right? That is the task. Now, how you do it? That's your choice. Like you use multiple times same imputer or anything. So any way you can do it. That's not a problem. The task is you have to remove null values, and you want to keep some values which are meaningful. So meaningful is in our case we are saying that, let's say the values which are representing central tendency of my data, which are
Okay.
mean, median, mode, I want to use that. So that's why I use simple imputer.
I mean, how can I know when should I use the median or mean or mode? I mean, how should I mean, how should I know that? I mean, why should
So
I use the mean, median, or mode? I mean, will be the case that I'll be using mean, median, or mode?
okay, so so do you know distributions of data, how that distribution goes on?
Yeah, it's the central tendency. I mean, that's the part you are asking, no?
Yes, but distribution of data,
Yes.
uh, like histogram,
Hmm.
or something, right? So how, if histogram is, let's say bell shape, like let's say it's a perfect, not
Okay.
skewed.
Then it's normal distribution, I guess.
Yeah, then what would be the best approximation? What
I
would the
guess
best?
mean will be the best approx because mean will be 0, I think.
Okay, yes. And let's say you have outliers in your data. How will
Yes.
you know from histogram that outliers are there?
I guess mode will be the best thing.
Sorry?
Mode. I mean, the part that occurs most, I guess, mode.
No. Histogram. I'm talking about histogram, not
I
about
mean,
mode.
histogram have something like the pillar kind of thing that occurs the most time. So let's say we get a experience in histogram in week 2 or something like this, that there's showing something floating or something like this. So
So it will be skewed, right? If you outliers, it will be skewed.
okay.
So you don't want to have, let's say, if it's a right skewed, left skewed, you don't want to use mean. I mean,
Okay.
median would be much better, right? So mean is affected by outliers, or mean is affected by larger values or lower values, right? So anyway, so you have to see the
So,
distribution of the data to decide.
Can you please give an example of this part? I mean, it will be really helpful if you can give an example of this. I mean,
Okay.
I know it's from statistics part, but
So let's say height, weights, which are normal distributed, right? Height, weight, something
okay.
like that. So let's say you want to estimate somebody. Let's say if I ask you, I have data and it's related to India, and I want to remove. So for few people, I don't have their heights. What would be your best guess? Then you'd say, okay, height is a normal distribution, so I'll use mean. That would be much better, right?
Okay.
But let's say if it's income data of people, then you have people like Ratan Tata, Ambani.
They are the
Then
outlier part, I guess.
there are outliers, right? So if I take mean of income, then there will be many people who are earning too much, and there are many people who are earning very less. And I
Then
mean,
the
I
distribution
use
will
a mean. The mean is, I don't know. I can't rely on mean. That's for sure.
okay. Yeah,
So
I get what you are saying.
yes, so that's where it
So
is.
we have to see the histogram to decide which transformation we are gonna do, right?
Yes, yes, you have.
Sir, if different features have different distributions, then but we are applying a collective simple imputation, no, sir. Like strategy is collective, same for all numerical features. Then how to decide, sir? Means as you said, if distribution is if skewed distribution, then we have to use mode. That sounds
Mhm.
logic. So if suppose different numerical features are different distributions, then how to approach, sir?
So you create a separate computer for everyone, right?
Okay,
So
but on the
see
tray.
here, what I did. Let's see what I did here. Let's see. I wanted to impute median. Okay, so that's why I wanted to impute median on this two columns. So I use this simple imputer. Then here, if you see maybe in locality, okay, I want to use most frequent, and I think I used somewhere I used constant. Okay, so here I want to do constant. So
Yeah, so that
why
means
I want to
feature
do
wise,
constant
yeah.
here?
Okay, okay. Feature wise, we have to take a call depending upon the distribution. Okay, sir. Thank you.
Yes, yes, you have to select, right? So here I'm doing fit transform, and I'm writing here which column what to do,
Okay, sir.
so that you can do it.
Okay, sir. Thank you, sir.
Yeah, okay. So okay, after we are done with imputing, so now we have
Sir,
values and all. Yes.
excuse me, sir.
Yeah.
Sir, what was that dot statistics function?
Yeah. Okay. So dot statistics is a attribute of my simple imputer class. So if you see here, dot statistics will give you the statistics or whichever statistic you use. So strategy, right? So here I use, that's the most frequent. Then for that strategy, my statistics is mod or most frequent. So which is this value, Bridgeport? It will give you the value of that. And let's say here I use
Got it,
median.
sir.
So after I use like median input dot statistics underscore, then I'll have median of this two column. So for estimate value, my median is this number, and for carpet area, my median is 1019. Okay. So that
Sir,
is X. Yes.
sir, if for a feature column, if there is a significant amount of null values, say for example 25 to 30% of null values, then for imputing those null values, if we use strategies like mean, median, or constant, that would disturb the distribution of the data, right, sir?
Yes.
So using strategies like mean, mode, or constant, instead of that, we should use other functions or strategies.
Yes.
So we need to create functions of our own, and then we need to import it.
Yes.
Okay.
Correct. So that comes under actually feature engineering. That you take something. So how do you want to impute? Let's say something you have to make. Let's say you are sure that it's a Bridgeport people have this much range of income, or you can let's say you take Bridgeport and you take like let's say carpet area or something. Let's say based on carpet area, this much is there. Then I'll use this value. So you can make this logics, but that is completely your bias. Okay, so you have to think really thoroughly before doing that. That should I do it or not? Okay, so I mean it should sound very convenient, or it should sound very good to everyone. That if you say that based on this I did imputation, then it should sound good. That okay, this is a better approximation.
Sir, I don't
Otherwise,
understand his question. Can you please repeat the question he asked? Then.
so let's say you had this data, and
Yes.
20-30% of data has null values, and
Okay.
you impute any value, let's say mean or median, something you did. Now your distribution has changed a little bit. It's just possible. I
And
mean,
how can I
mostly,
change the distribution using not using mean, mode, or median? I mean, central tendencies.
yeah. So you can have a different functions. Like you can create your own function and
Okay.
keep the thing. So generally in mean or case, like mean, if you use, you won't have distribution distortion or anything. You'll have same distribution, but with median you can have different distribution. Now histogram might change. Okay? But for mean, if you use mean as a imputer, then you will not have any difference. It will just same kind of distribution will come, most likely.
Okay. So his question is not using mean, median, mode, the central tendencies, but he's gonna use some other kind of functions to
Yes.
change the part in
Yes.
odds change.
Yes.
So how can that be the feature engineering part? I mean, how that's related to feature engineering?
Uh, okay, I think we should focus on quiz part, because
Okay.
if
Sorry
you
for
go away from this, then you see we are welcome you to ask this question when we take live session. Okay,
okay.
I don't mind. I'll give you all the answers, but today let's skip it.
Okay.
Okay, so let's focus, because
Okay.
otherwise I'll not be able to complete it.
Okay.
Yeah. Okay. So now let's see what encoders are. So uh, uh, I have like two encoders which are features, and one will come which is label encoder. Then in label, like there are different other encoders are there, binary or something like that. But the goal is we wanted to convert numbers to strings to numbers. Okay, so let's say I have ordinal data, which is like order is there, small, medium, large, or high, low, medium, something like that. So these all things are ordinal thing, right? So I wanted to have order like 0, 1, 2, and something. So that kind of encoding I want to do, then I'll use ordinal encoding. So you need to come up with yourself that this column, A column, is a nominal column, it's ordinal column, and all, right, to do this imputation. So let's say I have this column, or these are the categories I'm writing. So what will happen in ordinal encoding is that numbers might occur not in the order. So right, the order does matter here, right? This is the ordinal encoder. Order has a significance. So the whichever way you want, you have to define that using this parameter. So there is one categories parameter in ordinal encoder that you have to use, and you have to give uh, a 2D array. Okay, so
Sir, if
very
you don't give it, it will take in alphabetical order, is it?
Yes, yes. So if you don't take it, then it will take alphabetical order. So that's, if you go with it, then average will get 0, then bad, and then good, 0, like that. Okay, and we don't want that bit. So like I think here, yeah, I can show you. That. See. So let's say I don't have given any thing. Data is not defined. So this is, if you see now, my categories are like currently so average, bad, and good, right? So that's how it's categories were given, but that's not the way, right? That's not the way. It's incorrect. Like either it should give anyway. Anyway is fine, but it should have the uh, proper order. Okay, that's important. Proper order is important. So for that, I'll use this part, this categories parameter, and give a 2D array. That's very important, that I'll give 2D array. So why 2D arrays? Because sometimes you can give more than one column as well to transform. So for another column, you can write another array inside and give whatever values are there. So let's say like good, bad, and all are there. Then I can write in another array of this 2D array. Okay, so that's why this 2D array is there. So for now we have one, so I'll give one only. And if I run that, then you see the categories that are bad, average, and good, right? So like the way I give it, this is the way I have to give it. So I can decide which order I want. Okay, and yeah, so that is what ordinal encoding. So same thing I applied in few columns of our this house data to convert them, and in this way I did it. So like single family, 2 family, 3 family, 4 family, and you can see I am giving another column here as well. Sorry, another array inside, right? This how replace values in my residential column, details how to plex, triplex, then fourplex, something like that. Otherwise, it will be different, right? The order would be so that if you do that, then you'll have this orders. Okay. Now that is about ordinal encoding, but if you have not ordered, like nominal data, then you can't give order. Then the model will think that okay, there is some relationship. Let's say a male is twice of female, or India is twice of Sri Lanka or something. So, but that is not true. In some indications, if countries' name are written that way or something, right? So all the nominal kind of data we can't write in numbers as we did in ordinal. So we use this one-hot encoding. One-hot encoding is you represent them with 1, 0, 0 and all, right? So wherever the values, so let's say here the example is there, east is there, right? So these are like face value uh, of a house, that east face, west face, south face, and all. My houses are there. So I want to represent them. So what I'll do is I'll create 4 columns, and wherever my row is there, whereas east value, I'll give 1 to that. So here 1 is there, the rest are 0. Here again east is there, so that's again 1. West, then I'm giving 1 to west and keeping other as 0. So that's how you can do it, right? So a good question would be like how many columns you will get after transformation. So that is the number of categories, that many columns you'll get. So here 4 categories are there in the column, so that's why you got 4 columns. So let's say 10 categories are there, then how many 10 columns you will get. Okay, and there is another case is let's say you remove any one column, you can remove it, still it will represent the same data. You can represent the same data with 3 columns. So n-1 column is also possible. Okay, so that you can set here that you want to drop the 1 column or not. So without this parameter, it will not drop anything. It will keep all of them, and you will have 4 columns. Okay, so
So
that's okay.
one hot encoding gives one hot encoding use encoding as 0, 1, 2, 3, but
No.
I'm sorry, sir. Ordinal encoding encodes the categorical variables in more than 0 or 1, right? Like 0, 1, 2,
Yes.
3 in a single column. Whereas
Yes.
one hot encoder give a matrix like system with zeros and 1, right?
Yes. Yes.
Okay, sir.
So in one hot encoding, you will have only 0 and 1s, nothing else.
Pass output equals false. What does this signify?
Yeah, so this is a sparse matrix, right? So
Yes.
sparse matrix then which contains more zeros, like very high number of zeros. It's a sparse matrix. So to visualize a sparse matrix, I given the sparse output as false, so that I can have output and I can see that. Okay. Okay. So that is one hot encoding. So you will have one more is label encoding as well. So
If you didn't set it as false, then you can get the output. I mean, does this gonna have any problem for this?
sorry,
If you doesn't set that sparse output as false, then you're not gonna get output or something like this.
you will have output. It will say that it's a sparse matrix stored in this location. So it will give you memory location, and it will say that it's a sparse matrix. So if you want to see it, you have to expand it. Right? So you have to convert it to something. So
Okay, it's
yeah.
for visual representation that it gives you a matrix in 1-0 form. If you set
Yes.
it as false. Okay.
Yes. Yes. Yeah. So another is this label encoder reserve, which is very similar to ordinal encoder, very similar, nothing different. But the label encoder and the difference between ordinal encoder and label encoder is label encoder will only take 1D array. So label vector, it will take vectors also. So you can give 2D in this label also. I think 2D it supports, but that ordinal encoder will not support any 1D label, so it will not support vectors. Okay, that will only support feature metrics. Metrics are supported in ordinal encoder. Okay, but it's essentially same thing. You represent categories with numbers, so 0 to till 0 to n categories, n-1 categories. Okay.
So this label counter should be used only for target values?
Yes. For target, yes.
We can't use that for features, single features.
Yes, it's because no, I mean you can use it.
So single feature, how can you use it? Because it's on the array and features could not, I mean, not always be on the array, I guess.
Yeah, so it will, like, you can see using is not a problem. Okay, the what is your goal? See, the task or goal is you want to convert this categories into numbers, right? So that is the task. So let's say if I use from learn dot one hot encoder, say label encoder, and and yeah, one more thing is, see, in ordinal encoding there is a order, right? But in label encoder there is no order. You have to
Label
make sure.
encoder is applied only for labels.
Correct. Yes, you like um, by rule, yes. Okay, you can't use it on that, but
Data.
yeah, yes. But internally, it's a mathematic, it's a function, right? It's a program. You can bend it, you can mend it, whichever way you want, but by rule you can't. You shouldn't use
But
it.
we
Okay?
do not manipulate the labels. We always manipulate the data only. Why do
Yeah,
we?
but when you have labels in strings, right? Then you have to convert them to numbers. So
Then
let's
we
say,
have multi-class labels.
yeah, multi-class or just single, yeah, multi-class, multi-class labels, correct.
Got it. Thank
So
you.
what
Binary
did
class
you
as well,
say
but
just so what did you say just a second before? On which data label encoder can't be applied?
on
It's not can't
sorry,
be
on feature
applied.
metrics. You shouldn't use on feature metrics. You use it on label vectors, okay? But to show you, it works. It will
No,
work.
label encoder you can use for 2D array. I mean, it's only for 1D array, right?
Yeah, for 1D label, it. Uh, so I think it will work for
So
2D
why
as
not to
well.
use just ordinal encoder on the labels instead?
Because see labels, see it will support 2D as well. So why? Uh, 5 was passed when a 1D array was expected. Okay, so it will give you some error, but it gave the output. Yeah. To answer your question, see in ordinal encoder we expect categories to have a order, right? 0, 1, 2. So that's like something. But in label encoder, if you do that, there is no such thing was expected, since they are different classes, right? So when I
But
do it
sir,
is,
if you
yeah.
so but if you don't specify anything, if you don't specify the order in ordinal encoder, then we don't need a label encoder.
Yes, definitely. But ordinal, see, the issue you will face is, let's I'll show you when you will face the issue. It is so it is a vector, right? For example, I have images of dog. Yeah, let's go with dog, cat, and bird. Okay, so this is my images. I have images of this three. Okay, three images, three classes, and I want to apply one more bracket. One more this column. So dog is there, cat is there, and here.
Bird single quote you've given.
Yeah, okay. So this is my array, and I want to apply one ordinal encoder. Okay, so let's see. Ordinal encoder, and I'll do fit transform x. So x is that, right? I'm just not storing it anywhere. That's why I'm showing you. So it will throw an error that your data is not in 1D. Sorry, it's not in 2D. That's what this error is. If I make it as a 2D and there, so this is y actually. Y is always most likely going to be label vector. Okay, that's why we call it as a label vector. Most likely you will have a vector, and since all those cases you can't use this, right? So for that we have this label encoder. That if I use label encoder,
All
then
right,
it will
sir.
not throw that error. Okay. So now I have the encoding. So that's why I can't use that part.
It's the mathematical constraint. I mean, mathematical it sets like 1D array can be used only for label encoder. That's why you can
Mhm.
use. Okay.
Yes, that condition is set.
Okay.
Okay. Yeah. So yeah, and another thing is, if you use pd.get dummies, that's from Pandas, you can convert any column to one hot encoding. This is one hot encoding. Same thing, just the function looks different. Okay. I'm choosing face column and doing it. If you see, I got this. I got this encoding. Okay, false, true, false, and something like that.
What is block first?
So as I explained here in this, where was it? Yeah, here, right here I explained that to represent values n categories, you need n columns. But the good thing is you can drop any one column and still you can represent the same information. So that's a like we are, you know, to represent our data we are excluding one column, that we can do it. Okay, you can try it. If you have, if you, let's say I want to represent north and I don't have north column in this. Okay, I want to represent with this three columns, east, west and south. How will I do it? If I write 0 0 0, that means it's a north column, right? Without having north column I can represent it. So uh, that that's what this drop equal to first is doing, or here drop first equal to true.
So drop the first row
Column.
column.
Yes. Okay. Yeah, so now we have data imputed, so we remove null values. We have converted them to numbers now, and so we have data something like this. Okay, so this, if you can see, this is the way I have my data now. And the only issue now I have before training my model is I have it in different scales. Okay, that this is, if you see, this is at 64,000 something, right? So it's very high, and these are zeros and one and something. So the scales are very high. So if I use any model, it's a linear regression or an SGD regressor, which use gradient descent, so it's not a good thing, right? So for those algorithm, I want to scale them. Okay, so in decision trees and all, you even if you don't do scaling, that's fine. Decision trees, so I think you have learned in MLT, but we'll cover later on. But you got the point, right? That wherever gradient descent is required, or distance is required, for those all the algorithm, you need to scale this. So to scale this, we have this three lines, like standard scaling is there. So if you have learned Z score somewhere, that's the same thing. Z score is standard scaling. So I'm writing Z score after this. And what I'm doing is I have this all the values. I have this mean. I'm subtracting mean from the value and dividing it with standard deviation. Okay. So let's say this estimated value is s, and I want to convert this. So 647,220 minus whatever mean of this column. I'll take mean of this column only, estimated value column. I'll take mean of that, and on that mean, I'll divide that by standard deviation. Okay. Uh, so okay. Do run before. Same thing. Okay, so currently my exchange is like this. If I show you scaling part, so what I'm doing is actually, let's say I take x train, and I'll have Steve. No, I don't want minimum maximum. I want, so this I have, right? I can subtract anything from this. So what I want to subtract is see, you got the formula that I'm subtracting mean out of it, and then I have to divide by standard deviation. I will put a bracket here, and so these are the numbers it will transform to, right? Same thing the standard scaler will do. So let's say I have this, and I use estimated value. Yeah. So if I apply, then you got 0.364, and if you here see 0.364, okay, same thing, 0 minus 0.19, and I think that's the last row. So that's how you do standard scaling. And so basically what you are doing is you have this data which has very high mean value, very high standard deviation. Now you are converting them to bring the mean to 0 and standard deviation to 1. That is the task you wanted to perform. So that's what standard scaler will help you do it. Then you have mean max scaler. Mean max scaler is also very simple. What you do is you have the value here x, and you subtract minimum from that, and then you divide it by the total range of the data, right? So the maximum minus minimum is range from statistics. So you divide it by range, and you have some number. So you will have numbers between 0 and 1. There will be no number after applying min max, there will be no number below 0 and above 1. Okay. Then you do max absolute scalar. That simple as before, like x you have to take and you have to divide by absolute maximum number. So whichever is okay. So let's say you have minus 500, but in positive side you have 300. But you are going to divide it by 500. So you have to take maximum absolute of that maximum number. Okay.
So we are not going to use that. We are going to use the standard scalar function, right? I mean, we are not going to do the process part, I guess.
Sorry, I mean, why we are not going to use other?
I mean, we are just using the standard scalar function, or sorry, method to use this part. I mean, the coding part you are not using it.
We are using it, right?
I mean, we are using just a function that called standard scalar.
Yes.
And not using the code. I mean, we are not coding the standard scalar function, right?
Yeah. No, we don't need to. This all are already available to us. We are just understanding what this different classes are doing. How we can help. How we can take help
I
from.
mean, if I do some operation, then we just gonna import it from sklearn, which is okay. Okay.
Yes. So some attributes are given that you can take out mean of this column. So this is actually of carpet area, but if you see the mean of this is this much, and same thing, right? And here I did same thing. Okay, this is this test set. Okay, for test set you'll have something else. So you have to do that, right? After training, fitting on train set, you have to transform both the set, test and train. So fitting will only happen on training set, and transform on both of them. So this fit transform will help you do fit and transform that I'm doing on X train, and I'll do just transform on test. Okay, wherever I did it, I did it on test only. If I didn't, then that's a mistake. So if I do train fit transform to test set as that's a mistake of mine. Okay? Yeah. So now I have like this 2-3 things which are going on. Like I want to do encode, I want to clean the data, I want to scale them, everything I want to do, and I want to do it on various columns and across the various columns I have to do, and then one after another process also. Like it's a streamlined process. Let's say first I clean it, then only I will do encoding, and then only I will do scaling. So that's a like condition is a must do after that. So that's a like pipeline. You can call that pipeline, and there are like parallel processes going on that I can impute all the columns at once. Okay. That there is no issue with it because I'm going column wise and there is no dependence on each other. But since if I haven't completed imputation, then I can't go to the next step, which is encoding. So that's a stepwise process. So for that we use pipeline, and when we want to do something parallel. So remember that This column transformer is when I want to do something parallel, okay, across the column. So let's say column 1, 5, 6, 10 and something. So that I can do with some, I think, yeah, okay. So if something parallel, then I'll use column transformer. So the syntax is something you can look into it. So if I show you the syntax, you have to create a array, okay. This is the TF I am using here from there. It is an array which will contain tuples, okay. Tuples have 3 values. You have to give to it. So like you have seen tuples, like if this is a tuple, right? So let's say I write something like so this is a tuple. This is not a array or list or something, right? So this is a tuple. You have to give this tuple, but in this case we don't will not use all of them as a string. First one is going to be name of the thing you are doing, so that's your choice, okay. You have full freedom, you can do it. The second thing is not your freedom, you have to give the class, okay, class whichever you are using. So here I'm using simple imputer class with parameter set it. So parameter is my strategy and most frequent, so I have to give that class here, okay. Anything, and in the last you have to give a array which will contain columns, name or number, both will work, name or number. So let's say I want to give 1, 2, 3, that's also fine. You can give names also, but name will only work if you have pandas data frame. Okay, remember that only work when you have pandas data frame. Otherwise in NumPy there is no naming. There are no column names in NumPy. Okay, so if you have pandas, then yes, you can give column name also. Okay, that column 1 name or something you have to give, but you have to give an array. Okay, so that's how you have to write this transformer, this array, this array. So inside that the tuples, and as many tuples you give, you'll have this parallel things, right? So I gave 3 tuples. So one is mode impute, one is median impute, and one is mean impute. That's I have this 3 from that, and the last is remainder. So whatever columns on which I didn't do anything, I didn't apply any transformation,
Do
are
we
going to
use
combine
the
at last.
mode? Do we use the mode frequently? Median and quartiles are used, is it? Mean, median, and quartiles. Do we use mode?
Mod is this most frequent.
Mode is the most frequent.
Yes.
Yeah, that's okay then.
Yes. Okay.
All right.
Yeah. So here remainder is there, which will add rest of the columns. So we'll have this way, and we'll add rest of the columns to that. Okay. So that's how you got. So these all are parallel processes, and it's a good idea always to see the column transformer after you write this function, that am I doing correct or not. So it will, you can expand these things and read about that here this 2 columns will go here, this 1 column will go here, this 1 column, and remainder you'll not have anything to see, but the rest of the columns will come into remainder.
Sir, one doubt in terms of the exam.
Mhm.
Here, like, are we expected to know all the parameters? Like, are we expected to go through the documentation and, like, in case of column transformer, we have remainder, feature names out and all that. Same way, are we supposed to, like, are you expecting us to know every parameter and it uses, like, for other, not just
No.
column transformer, for other things also?
Yeah, so we don't expect you to know all the parameters, but we expect you to know which are popular parameters. Let's say in this
So
case,
once
this
we
is
used and once we are like mentioned and things you use so far.
Mhm.
Okay.
Yes, yes.
Is it
Which
what
are,
has been discussed in the lectures, sir?
yeah, which we generally use, right? So most likely we see. So let's say this transformer is column transform is there, right? The the most useful parameter in this is this transformer. How to write the transformer? You should know this, right? This without this, you'll not be able to make this column transform. So that's why this parameter is needed, and it's most important. So that's required. Okay. And yes, so that's how I wrote column transformer. And maybe one more thing. Yeah, this is a pipeline. Okay, so it looks a little bit containing many columns. So see here, I added one column transformer, then later on I gave another column transformer, then another scalar. So see the processes I explained to you. So first I'm doing imputation. You can see all the simple imputation, something imputation I did. Then I'm doing encoding, and after encoding I am doing scaling of that standard scaler using standard scaler. So this all are one after one steps, right? So pipeline you have to write, and pipeline, in that pipeline you have to give the steps. Okay, so steps are not looking too
So
good,
here,
but
column transformer in pipeline written 2 times, one for imputation. So you mean to say that every time when we are applying any transformation, any changes in features or columns, that refers to column transformer?
in any column or
Means
sorry,
in the given data set, if we are doing any transformation in any column or feature of the data set, so that means the column transformer.
that means the column transformer. Uh, if they are parallel, yes. So that's what we are doing. Yes. So we are doing it manually, but column transformer will do it efficiently. And you just need to write one set of code and
Actually, why this query arises? Here, one is CT, another one is CT2. So in CT, we are performing imputation, and in CT2, we are doing the scaling.
encoding. Okay. Yes.
Encoding,
Yeah.
right? So both are column transformation.
Yes.
So it refers that every time when we are doing any changes in the features or transformations, then that refers or that will give the column transformation.
Yes. 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 Yeah. So now all the things are connected thanks to this pipeline. Okay. So see, syntax wise, it looks little difficult, but don't worry. See, you can do it. Okay. See, it steps. It requires you to give steps. Okay. Some pipeline requires you to give steps. Steps is again very simple. You have to create an array, and again you have to choose tuple. But this time you have to give two things because columns are not required, right? It will go all the columns. All the columns will go in this. So selection of column, that option is not there. So you just need to go to the name of this and the thing itself, right? Whatever transformer is there. So it will apply transformation on all the columns together. So here you go this way, then CD2, then I'm doing this scaling. Then I am doing feature scaling. Sorry, feature selection I'm doing. Is it this RFE? Then I'm applying a model on that. So I can create the whole thing and I have it now. Okay. So whenever next time I have a test set, I just need to do, I've then done it. See, I am using the pipe.fit extend white train and I can get, yeah, so I can again do fitting, sorry, not again, but I can learn from that and use that on test set if I have done it. Yeah, I think I haven't done it, but that is the idea, right? So,
Just above this line which you showed just now.
oh, is it?
fit. You showed fit, transform, and extreme. No, about that you had done it for the test.
Okay, so let's see. Still show some error.
Excuse me, sir.
Yes.
Sir, I have to leave, but I was patiently waiting for you to start discussing about linear regression so I could ask about my doubt. So could you just
Sure.
resolve my doubts so that I
Sure.
can leave?
Uh, okay. The way, okay, so I think your doubt is related to the coefficient question, right? Which W2 and W1 is given, how to find W1. Is it?
How do you know, sir?
No,
Because I posted it in the source.
no, I have experience that people ask, students are getting stuck there. So that's what. Yeah, okay. See, I'll tell you, okay? See, okay, in school, if a line equation is given to you and the points were given to you, okay? So let's say points and line equation given to you, what will you do?
Sir, I will try to adjust the line to minimize the error.
Mhm. No, let's say you have given line and given the point from which the line is passing through. It's a very accurate. Said that there is no error.
Sir,
Okay, let's say it's been
sir,
told there is no error. How will you go then?
sir, there is no error, then that means that the line, all the points fall on the line.
Hmm. Right.
But, sir, if you observe that question, the first column is enough to predict y, right? May I share my screen
Sure.
for
So
that
this
question?
this question, right?
Yes, this one. Yes, sir.
Okay. Yeah. So
Yes, sir.
so what is the issue?
Sir, how, first of all, if you see the feature vectors, it's actually the first column is enough to basically predict y values. And the coefficient should be 0.5. The first coefficient should be 0.5, but instead it is 0.3.
No, that's how it doesn't work, right? So see, this data is in x1 and x2, right? So you can't say only first is enough because I have this point in somewhere, right? In that's a 3D space. Points are there. You want to pass a line through it, correct? So
Actually, sir, I too not able to solve it.
then what about the other? I mean, it will the other column will give you the point in 3D, right? Or 2D, uh, whichever case you put.
We are already given a relationship between W2 and W1, so we have to have two weights. If one weight is zero, then we won't get the answer.
Sorry.
No, in the question they are giving like a relationship between the weights also. W1 and W2, you have to have that relationship. If
Yes.
what he's saying is right, like if you're only taking one feature, like one value of the feature, then the other will have to be zero. So that model won't work. So we can simply use that relationship and make a equation in like one, like we can take out that W1, then we will have an equation between like x1 plus 5 by 7 into x2. We will get a matrix with that. You can
Yes.
solve and get the answer.
Yes. Okay. Is that?
Sir,
Sir,
could you
I'm
please
still
solve this
at,
question?
yes, sir.
Actually, I'm not able to solve it mathematically too.
Okay. See. Give me a minute. Hello. Give me. See. First let me write the question. The question is that y is equal to so okay, w0 plus 2 plus epsilon. So epsilon is a error. Okay, that's what error is. And given that error is 0, so there is no error. Okay, so it has to pass it from all the points. Okay, then there is a relationship given that w2 is equal to 5
Is it
times.
really specified in the question that the error is 0?
Yes. Yes, that is
Could you
specified.
show me where it is specified?
Epsilon, right? This epsilon, that's how this equation is written, right? Y is equal to W transpose X. Let's say if you take that.
In the question only, it is given epsilon is equal to 0.
Yes, that epsilon is error.
All right.
Yeah, it's given, right?
All
So
right.
error is 0, okay?
So
It
I
has to.
confuse it with mean squared error.
No. Error means, yeah. So there would be no error. It has
So
to
it's the
pass it from.
intercept, right? So it's the
No.
intercept, right? I mean, from this equation, because in the question it's like fit underscore intercept equals false. That's why. I mean,
That is,
I'm talking about the
yeah.
epsilon.
No. See,
Intercept is 0.
okay. Let's
W0.
say we have this points, okay, and this line is passing from it, okay. And let's say if I say don't choose intercept, that means it will go through the 0, 0. Let's say this is y mine, and this is my x1, and let's say this, the axis which is coming out is x2, okay. This y. So my line will pass through 0, 0. That's what this intercept equal to false will say. But this is not error equal to 0. This is being informed by y epsilon is equal to 0. So wherever this line is going on, or wherever these points are, from that this line is passing. Okay, it's like that. So that's what this will make 0 intercept equal to false will make this one 0. Okay, uh, uh, because this is given intercept is equal to false. Okay, this is given. So this will say that choose w0 equal to 0. Okay, this is from that I get it from that.
Sir,
Now,
if it's an intercept, sir, if it's an intercept, then why it is even having x naught? It should have only be W naught.
Uh, okay. Okay. See, this is equation of line, right? This is not this generalized equation of line. Okay. This is not. I mean, I can remove it. Still, it doesn't make a difference. In our case, I'll generally X zero is always one, right? We what we do is we write like W0 plus W1 X1 plus W2 X2, something like this we write, and we always consider one here X0. We never consider them, but when you do matrix multiplication, you have matrices this let's say X and W's, right? Whichever way you do it. So let's say here this X1 is there, X2 is there, and here your W1 and W2. Now you have one more intercept in your picture. So what you do is you add it here, and you add one more column also, one. So now the multiplication is very easily that W0 is multiplied by 1 plus W1 X1 plus W2 X2, right? So so that's why we add 1 here, and X0 comes into picture from there. Okay, this extra column we add, that's okay. Yeah, so we know so okay, so I have laid everything. Now we know that F, okay, W2 is 5 by 7 W1. Okay, one part is solved. Now given some points are given which are passing from this line. So this line is there. Let's say this is 0 comma 0 in X, and in Y it's a 0. Okay, then here it's being told that this is yeah, see all the points are written like this, right? 0 comma 0, then 2 comma 1.43 and something like this. Okay, so they are each point. So this is 1 point, this is another point, and something. This is 1.43 given, and it's being told this is 1. Then another point is given, which is 4 comma 2.86. This is 2 value. So I'm not plotting in 3D. This is like you can say, but this the values are 0, 1, and 2. Okay, you can say this is a 3D or something. Okay, like this, x1, x2, and y is coming out or something. Any way, or this is x2 and this is the whichever. Okay, so yeah, so let's say I take this point. If I take this point, this is true, always true. I mean, I will not get the answer. So I can't. Both side will become 0. 0 equal to 0. So hence proved. I mean, it will not work. Okay. So I'll use first point. Let's use this one. So what I have to say is I have this y. First term became 0. So now I have W1 X1 plus I have given relationship of W2, right? So which is I will write 5 by 7 of W1 and X2. Okay. Let me take W1 common from this, and it's like X1 plus 5 by 7 X2. Okay. So the point is this is 2 plus 5 by 7 of 1.43. Okay. And this is W1, and Y was given 2. Or 1, sorry, 1. 1 is given. 1. Okay. Yeah. So from this we can find W1. W1 is 1 divided by 2 plus 5 by 7 into 1.43. Okay. So this whole sum is together, and you get, and you can find out whatever values. So I think it will come out 0.30 or something.
And this is going to be true for all the points.
Yeah, for all the points, because see this is just the, if you see, okay, see I'll show you one another points. You have 2 comma 1.43. Okay, then you have 4 comma 2.86. If and this is 6 comma 4.29. Okay, if you see this is 2 times of this. Okay, and this is I guess 3 times of this. So first, so if you do row echelon form, then ultimately you will have this one. Okay, row echelon form. If you can remove this 2. So you will finally have this one only, and 0 comma 0. Of course you can't remove that. but this 3 you can remove. Okay, so like row echelon you do. So that's a long like elongated way, but if you want to go there, that's a choice. But yes, it's true. Okay, this is 3 times of this. So it will always pass from all the points. 0, 1, 2, 3. Y is equal to. Okay, so
Sir, can you scroll up and show the equation, sir? Just top. The top. The top. So why we use only till W1 and W2, sir? So we have W3 also, right? So we are not using that?
We don't have W3.
We don't? Okay.
We have comma. So there is a comma, like 2, comma 1.43. So this is point, period.
Thank you, sir.
Yeah. You can see the 19th question.
Sir, no W0? No value for W0?
Because it's being mentioned in the code that intercept equal to 0. This because of this. W0 is equal to 0. Yes, it's there, but we have considered it as 0. Okay.
Yes, sir.
And what will happen if suppose epsilon is 0.01?
If epsilon is 0.01, let's say 0.1.
What does the result will impact it?
Then actually I think I can't solve it manually. Because see the whole point is let's say this is here 0.1 error is coming. Now what I'm saying is this line is there. The all the dots which are in this might be here off, let's say something, or could be let's say 3 are on the line and 1 is off or something. Now let's say I pick this one and let's say this is something like this. Let's say this is off of the not on the line. Rest are on the line maybe. Okay, and this is not on the line. When I pick this one to calculate my W1 or W2 or something, then I'll not get it right. I'll not get the correct W1 because I want to find the W1 which is for line, right? I mean line does exist, but I will not be able to find W2. I need some points. If I give you that this 2 points, let's say these 2 points, some points, any epsilon, let's say epsilon is equal to 5, 4, anything, but I give you that this 2 point does exist on the line. By like sure there does exist on the line, then you can find it. Otherwise you can't. So
Similarly, suppose if it is an intercept is not 0.
Intercept is not 0, then you have to take
W1.
So now let's see. Now the issue is you will have W0, right? Let's say x0 is 1. Okay, 0 is 1. Now you will have W1 x1, W2 x2. Now you have y. The only relation is given between this and this, right? So maybe you can replace this. So, but you still have one more variable, and you have only two.
And they got to give another relation, is it?
Right? Yeah. You only have one equation. Sorry, you have one equation, and you have 2 variables. So it's a unsolvable set, right? You can't solve this. So that's also not possible.
Okay.
Okay. Yeah. Should I complete this feature selection part then?
You have one more class?
So let's see how to share the screen.
Sir, even if there is an if there is an intercept, you will have two equations, right? If you are using the metrics, you can still solve it like the way we solve in MLP, taking the
If
inverse and
you
multiplying. We can,
yes, definitely.
yeah.
Matrix multiplication you can, but ultimately you'll have equation, right?
Yeah, but it will be like it will be equally right. Like so, it will be different equations because we are just adding a W0. We are not multiplying it with any X or anything. It's just one. So it will be different equations, right? It won't be like into like scaled equation. So it will be two different equations. First one we are adding a W0. Second equation also we are adding a W0, and so we will have like two labels, and so it will be different equations, right? In the end.
Sorry. Can you repeat the question?
No, I was saying like we are adding a constant to both, right? We are adding a W0 because
Mhm.
X in the set it will be one. So in that case, it will be two different equations, right? We will have like separate labels. Labels are different labels, and we will have like we are adding a constant, so it will be two different equations.
Yes.
So you can
Two
solve it.
different equations.
It won't be like a scaled one, right? We are not doing two W0 on the second one. We are just adding W0.
Mhm.
The first one also we are adding W0, so it end up become two different equations.
Yes.
I think we can still solve it. Like we'll have a solution if you use the metric.
Okay. Yeah. Could be possible. It could be possible. Yes. So, uh, so I'll take feature selection. So, we have few like variance threshold is there. So, variance threshold means you are saying you have some variance. Okay, some data is there, and variance, the sigma square, right? The variance, if sigma square is less than some value, then you can drop it. So that means you are saying that if my data is doesn't have any variability, then it will not contribute too much in predicting my label, okay, label or target. It will not help me predict my target too much if there is not too much variability. And that is true if, let's say, all the values are one, or let's say all the values are same thing, that means there is zero variability, and there's no contribution by that column in predicting anything. Okay, so if something is there, we can remove columns which has threshold of something, okay, less than some value. So five, less than 5 variance, less than 10 variance, less than 20 variance, 1000 if you want to remove. So you can choose those values and you can remove it. Okay, so there is no hard rule how much variance is required or something. There's no such thing. You have to decide it by yourself. Okay, that this much variance or less is there, I'll remove it. Okay. Yes. Then yeah. So another is select
Sir, what is that state transform is equal to pandas?
this one. Yeah. So in sklearn you will have all the transformers. So this variance threshold, column transformer, pipeline, previously did encoder, imputers, scalars, everything will give output in numpy. But I don't want in numpy. I want back my pandas data frame. Okay. So to get that back, I am using the set output as pandas. Okay. So this is a thing you can use to make your numpy array, or you don't want as output as numpy array. You want in pandas, because pandas are visually very good, right? Then numpy arrays. I mean, you'll get confused or something. So For that, I use this one. Okay.
Threshold equals 5. What does signify this?
So
Yeah.
threshold. So like I said, in variance threshold, you can remove columns which has variance then some threshold. So this threshold I have set, there's a 5. So whichever column is less than 5 threshold, it will be removed from the data. That's feature selection. So you're removing or keeping the columns which are greater than 5.
Okay.
Wait,
How could I mean, calculate the threshold part?
yeah. So okay, I just said it that this threshold you have to decide it, and that you can do if you have some knowledge about data. So that is a kind of domain expertise. Or if you don't domain expertise and you still want to do it, then what people do is they take 95% of data. I mean, they set the threshold in is such a value which will keep the 95% of data columns. So let's say you have 100 columns, and whichever has least five variance, you want to remove them, something like that. So that you can do. Or I mean, there is no hardcore way how to do it, or how by 5 I wrote. You can choose any number. That's your choice.
Okay, sir.
Yeah.
Sir, this method is to remove features.
Yes.
Variance threshold.
Yes.
Same
So
like a recursive feature elimination.
yeah, same. So that's a feature selection technique, variance threshold. We are based on variance, we are removing the feature.
Okay.
Yeah. Now, yeah. So now
Sir,
another.
sir, I have a question regarding feature selection.
Yeah, go ahead.
It has a government relationship with our projects. If it is a classification problem, which feature selection is best suited, sir? Like we have so many methods like RFE, selector model, and select K best. So many feature selection methods are there. So which one would
Okay.
be better in which scenario? That.
Okay. Okay. See, I'll cover that. The answer is here only. Okay. So, see, you'll come across select K best, generate univariate select or something like that. Okay. So this all things select K best and all select percentile. This all are just a selector. Okay. They are the one who set the boundary. They don't do anything statistically speaking internally. They are just based on score value. It will uh, it will remove some features. Okay, so that's what the select table select percentage and generate univariate something like that is there. Okay, this all do, but internally what statistics is using, there is one chi-square. So you have heard of chi-square test. So that's what internally being used by feature selection here. Okay, so not here where I'm using that. Here I'm using here. That score function is chi-square. Okay, so that on that basis I am selecting features. So you'll have two things in any feature selection. One is score and one is p-value. The score, the higher the score, better the feature is. So that feature will get selected. So let's say 10 features are there, or let's take 5 for example, and I have values of score like let's say 4.5. So this is actually size. Yeah, actually chi-square value or something. So I have let's say 22.3 one, two, three, point. Then let's say 44. Then maybe 5.6. Then I have like 12.1 or something. So this all are there. So these are let's say scores value. So higher has the chance of selecting first, right? So let's say 44 will have the highest chance. Then this one. So if I use k is equal to 1, then this will get selected. If I use k equal to 2, then 44 column and 12.1. So this is a chi-square value related to one column. Okay, we can see that I'll show you that also. So and then the chance of getting selected is this. So if I use k equal to 3, k equal to 4, and k equal to 5. Okay, so same is percentile. If it's like 50 percentile or something, then or let's say 80 percentile, then top 80 would get selected. So top 80, maybe this and this could come under top 80, or maybe this only come under top 80. Okay, so that's how the select percentile goes on. Then generate generic, sorry, this generic univariate select the same as those two. Okay, percentile and all. In this you have to give mod. So here I gave percentile. You can use this. I think you can give k best and then the selector. Okay, so function, score function. So here I am using chi-square. So this is chi-square and f classification, f score. Okay, this two will help you in classification task, and in regression you have to use f regression. So f value for regression, that will come under regression part. Okay, so if I show you how this works, we done this. So I have this iris data. Okay, I have iris data. From here I'm taking it. And, I'm running a score and p value on that. So if I show you the scores here, I have scores, and this all scores are there. So if I say which has the highest chance, this one. Okay, then second and third and fourth, you can rank them. So to rank them, I can use arc shot, right? Arc shot is there, which can do it, which is this one. Okay, so arc shot can, so it does rank them in ascending order, so from lowest to highest. So since okay, see if I have columns value like 1 5 1 3, let's say 8 2, I want to sort them in increasing order. Okay, so what I can give is I can write like list doesn't have arc short or something, but let's say if not, then I'll convert it to number. Okay, list doesn't. Okay, so parent again, then I'll have some value, right? So it's saying that if I arrange, if I want to arrange these words in increasing order, then I have to use this indexes. So let's say array 0. Array 0 is 1. If then array 3. Array 3 is 0, 1, 2, 3. So 2, right? Then array 1. Array 1 is 3, and array 4 is 8. So that's how I can arrange my words. Okay, so let's say 5 comma 6, and I run that again. So now it's saying array 0, which is 1, array 3 is 0, 1, 2, 3, which is 2. Okay, array 1, which is 3. Okay, now in our case it's 4, then array 5 is 5, and then 8, right? If you didn't get the point, what I'm saying is, let's say I have this array. Okay, this array is there, and I want to sort that. So I want to sort that. So what I can use the array, you know, right? How if I write 0, I'll get zeroth value, which is 1. Then let's say I want 0 and 1. I can't give like that. I have to give this. I'll have 0 and 1. Okay, whichever is present at 1. But what if I give this arc short uh, thing, which I got it from here? Let me give this one. Okay. So it will arrange them in ascending order. So according to value, it will be in ascending order. Okay. Very important, ascending order. So now I have all the values arranged in ascending order based on this. Okay. So based on this, I can say that 5. So 2 is the highest score value. Okay. Based on this, 2 is the highest value, and 5 is second highest value. 4 is third highest. Likewise. Okay. So you can use arc short to figure out which has the highest value and choose that. So let's say if I tell you choose best 3, select 3 best, select k best, and the k is number, select 3 best. So this are the 3. Okay, so that's how it goes. So you can see scores, and p value is opposite of that. So the lesser the p value, will have higher the score. Okay, so lesser the p value, higher the score, something like that. They are inversely proportional to each other. And so we have same thing. Then I have this wrapper based methods in which I have to use a model. Okay, I can use on any model. So let's say RF is there, I have to give a estimator. So here I'm giving linear regression, and I have to define how many features I want, and this is for converting it to pandas. So I use that, and I'll have some features. Okay, so in RFE, so RFE is like based on ranking or column coefficients, right? So coefficients I'll get. So based on this coefficient, or some model will give feature score or something like that. Okay, you will have something like that.
Feature importance.
Yeah, feature importance. Okay, so feature importance or coefficient. Based on that, it will select this features, which are as higher coefficient or higher feature. Sorry, I again forgot. So that. Okay, so you can have that. Then sequential feature selector. So you can go backward or forward. So any direction you can select. Okay, so in forward you start from 1 and then add 1 by 1 and then train the model and select it, and backward you remove 1 by 1. Okay, something like that. So that is also there. Then okay, so this is scoring method. So you know like how mean absolute error works. You take y minus y hat is the prediction, and you take the mod of that, so absolute value only, whichever way is, and you add them all. So that's how you compute mean absolute value. Then mean squared errors, so you square that y minus y hat, then find it, then you mean part I forgot. So you take mean is divide by number of values, right? And here then R2 score is 1 minus y minus y mean, and divide by y minus y hat. Okay, so you are comparing basically with mean. I might have it, but you are saying that if R2 score is less than mean, that means you will have values lesser than 0. Okay, if your prediction is as good as mean, let's say predicting values as good as mean only, you're saying that mean itself. Okay, then a 0 score, R2 score you'll have. If it is better than mean, then you'll have positive values, and of course, like 1 means you don't have any residues, right? So line is passing from all the points. So that is R2 score equal to 1. Yes. Okay. Then
I guess in week 4 we have linear regression, which is
Sorry, sir, to interrupt. Can you please explain R2 square and p-value? What's the significance for this in model evaluation or
so
inequality?
when you do feature selection, p-value should be very less to get that feature to select. So whichever has very less p-value will have a very high score. Okay.
Okay.
So that is that. And another is R2 score. So R2 score, the equation of R2 score is 1 minus you subtract with compared to mean. Okay, so you are comparing. So let's say our model is as good as mean, then uh, then 1 minus whatever you are getting will come as 1. Okay, so R2 score ultimately will come 0. I'm talking.
So
Sir,
in the lectures, the lecture says that the denominator it is mean of the prediction, but it's mean of the true value, right?
Mean of true, yes. Mean of true, yes.
I think it's even in the slides it's written as prediction, so maybe I need to correct
Okay,
it.
okay, maybe then. So you take. I mean, I am.
I mean the
From.
value we are getting from
Hmm.
calculation, it's when we use true value, we are not getting it from the prediction, so it has to be the true value.
So in the numerator is y minus y prediction and the whole square, and the denominator it is y minus y mean of y prediction in the
No,
denominator part.
no, y of true, it's mean of y of true. It's just
Yes.
Where? In denominator.
yeah, in the denominator also it's y of true. And
Mean of y prediction, no. It's
Y
y,
of true, y of true.
mean of y prediction.
Yeah. No, not prediction. Not prediction.
But sir,
Only.
that is what is given in the lecture slides.
yeah,
Uh,
I think
that,
it's a mistake, that's
that's a mistake. Not
Oh.
from predictions. Okay, and I think. Okay. Wait, give me a minute.
we take the difference between the true value and the predicted value and square it, and then we do the sigma of that, add all those and divide it by we like square of the variance, like without dividing the like whatever we do to calculate the variance, we don't for the true labels in the denominator.
So how is it, sir? Now the updated thing is y minus
Y hat
y hat the whole square
divided
by y minus
the whole square. Y minus y hat the whole square is all in sigma
Yes.
divided by y minus y actual whole square sigma.
Yes.
no,
Y
y
minus
minus y bar.
y
Y
hat.
bar, y bar.
Yeah, y hat is sorry, y bar. Yes, y mean. Okay.
Y minus y mean.
Yeah, y minus y mean. Okay. Y minus y mean. Yeah. So bar or whatever. So give that. Okay. So this is R2 score.
Sigma you have to summation.
Yeah, of course.
Minus y hat summation.
Of course.
Of course, yeah.
So that's then okay. Just okay, and you have summation.
In denominator also summation.
Yeah, both. It's for both.
Separate summation, no sir.
Separate or
Yeah, we do it separately, so only then we are
separate or together. I think it will not make much difference. It will not make difference, right? Because you'll have y1.
no, we will do it for the individual points, right? We'll do it for the individual points and add up. So,
Yes.
we cannot submit together like how like
Yeah, could be. Okay. Yeah. So
The summation is this.
Slash sum. Yeah. Correct, sir. Now it is correct.
And I can be right. Uh, so something like this.
Correct, sir. Over.
Yeah, this is artificial. Okay. Yeah. So you know how. So linear regression is
What is y hat and y bar here? I don't
y
understand.
hat is predictions and y bar is mean. So you
Okay.
take mean of the
Actual.
actual, okay, the truth or training set or whatever you call it.
Okay, sir.
Whenever you compare it,
Okay, sir. Thank you.
not the yeah. And okay.
Sir, here n feature select equal 4 is given. Na? Suppose after 1 hat encoder, we may get say 1500, 800 features. So how to choose these numbers or n features to select? Here in example 4 is given, but in practically it will not be 4 or it will be more only. So how to arrive that number, sir?
Generally, there is no rule. You have to choose a number. So yes, you have to choose a number.
And sir, regarding my last question, which
See here, yeah. See what you can do is what I can say is you can use maybe select percentage.
Select percentage.
Okay, so let's say you want to keep 30% of the data.
Okay.
Then you can do it there, right? So let's say keep 30% of the rows based on some scoring function, right? Some scoring function, keep 30%. So you can do that using feature percentile way. So that is one way you can do that.
Okay, sir.
Okay, yeah. Okay, so yeah, I think that's all for today.
Sir, one thing I want to ask.
Yes.
Actually, how to remember these libraries and the features we are importing in those libraries? Because for me, these are very confusing, and this will means surely not help me in OPP if I don't remember.
Okay, so see, I mean, correct, correct. See, this is what you can do is um, you will get idea that what you want to do, right? So first you should have a picture that let's say this pipeline I created, right? I had a picture in my mind that what I needed to do because now I know that I have experience, but this is the picture that I want to first clean it. Then I want to convert my categories to numerical. Then I want to scale it. Then I'll do some selection, and then I'll use linear regression, something model. So that's my thing I wanted to do it, right? That's a picture in my mind. And how to do that? For that, I need this things and all. So I did it. Okay? So that is the picture. This will actually help in remembering that what you need to do. Now, how you do it. That will come with the practice. You have to do. I think if you do it for 3 data sets, let's say 3 data sets, take any unclean data, three, and you solve it. You do this. Okay, you create this part by yourself. I mean, if you get stuck, go to the library, read it, come again, then write it. So for first time, you'll feel stuck at many points. But this is a picture. You have to see this. You have to do this. And second time, if you do it, and when you'll do it for third data set, I'm sure that you won't need to go back to the any library or anything. You'll remember that.
Actually, I get stuck somewhere in the starting when I use from SQL and dot something import, right? So means from, for example, from SQL and dot linear underscore model import. So how many means the features or values we can import from the sklearn or linear transfer model. So actually, this is one of the step point for me. It's like
How
I used to
how
forget how many things we can import from one library.
from where, right? Yeah. So what you can do is you can write directory, right? So see, for any class, let's say I imported this from sklearn, and then something are there, it's a pre-processing or something. Okay, I don't recall them. So if let's say I don't recall at all, then I need to go first like import sklearn. Okay, so I have to import that. Then I have to write like directory. So this will show me what is there in the sklearn. Okay, um, okay, something. So it will show me all the names of it. So let's say like compose is there, cross check on a data set, and which we use. Okay, data selection we use, impute we use, linear models, then let's say model selection, pipeline, right? All of them are there. Now let's say you go inside any of them. If I go inside, let's say pre-processing, so let's say from sklearn import. I mean, this is a broad way to see what is where, but still, you need to remember something. I mean, something that pre-processing is the one which contains all the pre-processing tools, like which you require to clean the transform the data, right? Encoding and scaling, which will be there. So something you have to remember, of course, but I mean, I'm not sure how you can remember this without practice. Uh, Without practice, I don't think that's possible, though. But yeah,
Yes,
these are some things you can use.
I'm doing that, sir, but now this process will help me directory process.
Yeah, so this you can use that. Let's say directory you write, then you'll have all the functions which are available in this. Okay, so some which you not use in this course, but you can read about it. You can maybe go back to the this documentation and read it.
Sir, during OPP, will be allowed to use documentation, sir?
Documentation. No, there will be one SQL and PDF is there, which you can use it. So in that, I mean, you can't use documentation like this, like this website, but the way you can use it, you can use, you have to use actually collab. So the main task is you have to use collab,
Sir,
right? So you can
earlier
use,
collab was not allowed earlier.
sorry,
In,
when?
in OPP, when during Python exam or this MLT OPP, the collab was not allowed. Means you are providing some interface. Collab was not allowed. Now collab is allowed.
Yeah, it's allowed. Okay, so you can like, let's say pre-processing, I want a standard scalar, something like that. I can, do this and I can read about it. So this is a documentation only. Same thing, but it will not look that good. But you can use this thing like example is there. Still, if you want much better, then the way is what you do is let's say
But like this pipe P, if you write pipelines coming, no, sir, that one all will be available, no? Like auto filling.
that I'm not sure. Currently, this is because of this Gemini. Okay, this Gemini. Please mute.
Yeah, there's a mobile later. Yeah. Let go. My backlog. Mobile.
Okay. I was explaining. No, see, currently this auto this thing coming up because of AI feature. Okay, so this assistive AI, to be frankly speaking, this is the first time they've introduced for us. I mean, you might have seen it if you used Colab before. Then there was no AI.
Yes, sir. Earlier it was not there.
It was
This
not there, right?
time,
So this time it's there, but I'm not sure if they will allow. I mean, they will.
in OPP, they will means
They might
will be
disable that
allowing or not.
feature. So don't rely too much on that.
Sir, then while practicing also, how to disable that, sir? Can you show us?
That you can do it. You can go to tools and this AI assistance is there. You can hide this one. So see Gemini. If you see this Gemini part will go away and the other also. Okay. So that you can.
When there is a feature available, why do you not allow it?
Okay, we will discuss later on. Okay.
Anyway, it is going to be there in the industry, is it?
No, it's not that because if we give that, then there is no point in taking OPP. I mean, see, what we can do is either make this MLP course as pass and fail course, and don't make it credit course. Just if you pass, then MLP something, then we can do it. Otherwise, we can't. If there are marks or grades given to us, I mean, yeah, grades given to you, S, A, B, C, then we can't give you. Then something you have to do.
Okay.
Sir?
That we will discuss during
Sir,
OPP.
yes.
Okay, for quiz 1. Sir,
Yeah.
you are recording,
Quiz
sir. We will
one,
stop
till
it after some
subjects.
time.
Yeah. So we'll close the session.
So before closing,
Sir, don't close it, sir. Stop the recording.
I mean, so.
Sir, what about the week 4?
I mean, sorry, don't stop, close it.
No, you can stop the recording, but don't close the session. We have some more
Okay.
doubts.
Yeah, but it's very